Hi there, my name is Michael Moore, founder of Double M Game Dev, and my goal is to make you the best game developer in the most fun way possible. The video you are about to watch is a course that I have on Udemy and Skillshare. It has thousands of students and hundreds of super positive reviews, and today I'm going to give it to you for free. Well, not all of it, because I still have to pay my rent somehow.
Give me rent.
You'll get your rent when you fix this.
You can support me by leaving a like down below or a comment telling me how amazing this course is. And if you get to the end of the video, or you are anywhere in the middle and you feel like you want to get the full 15-hour version of the course, you can go down into the description where I've left links that you can use to get special coupons and save you a bit of money. I'll also leave a link to my Discord server where you can go ask questions, answer questions, and just interact with like-minded people. Also, if there's any problem with the links, you can always leave a comment down below in here telling me of it, and I'll reply in a matter of hours. Now, before we move on, I just wanted to give you a quick guide on how to navigate this long video. If you are a complete beginner, then I recommend that you watch this video from the beginning until the end. If you are already familiar with C# and Unity, then I recommend that you go to the following timestamp. This long video should have chapters down here on the red bar, and if it doesn't for some reason, because sometimes that happens, you can go down into the description or in the comments where I will pin one of my comments with the timestamps for every single chapter. That way you can watch one part of the video, then go relax, then come back, and you can select which chapter you were last at and continue from there. I also recommend that you watch the video that is right after this one, which is called How to Use This Course, which is a very important video. First of all, it will motivate you. Second of all, it will tell you what each section is going to be about and just give you a general idea of what will happen. Finally, since we're creating a game in this course, I thought it would be fitting if we play a little game of our own.
I want to play a game.
No, it won't be that kind of game. During this course, I'm going to leave you with 3 secret hidden messages. These will pop up at random locations on the screen and at random times. And if you find all 3 hidden messages, you can contact me via any medium. Tell me what the secret messages are and what time they appeared, and I will give you the whole course for free. Anyways, thank you so much for watching. Let's not waste any more time. During this video, I've solved the Rubik's Cube. If you haven't noticed what happened, then you're not paying enough attention. So, put your concentration caps on. Let's not waste any more time, and let's get started. Hey, welcome back my fellow game developers. So I've created this video in order to set you up for the rest of the course. I wanted to create this video in order to maximize your learning potential from this course, so you can leave this course with the maximum amount of learning that you can possibly squeeze out of it. So first of all, let's start off with the Q&A. And we'll talk about the Q&A in the Udemy section. So for example, let's say you are going through a certain video and there's something that you do not understand, or there is a piece of code that maybe is too complicated for you, or you're not sure how it works, or maybe you even have a little bit of a better idea that you want to tell me about. So you can do that in the Q&A right here on every single video. And here is where you can actually contact me and leave me a Q&A. I usually respond either immediately or after a maximum of 12 hours whenever I open up Udemy and check everything. So you can here ask me a question about anything that you see fit. Now, there are a couple of steps that you need to follow just in order to maximize the potential from these Q&As. So first of all, you can go ahead and search for the questions that are already asked about this course. So maybe your problem has been already solved by another user, or maybe I've already answered the questions. So you can go ahead and search for the question that you are seeking, and then you may go ahead and ask your own question if you don't find the solution to it. So first of all, you need to make sure that your question in the title is very clear. So make sure that you put the main idea of your questions in your title, and then you can go ahead and describe what you are trying to achieve from this question or where you are stuck. And in here, I recommend that you use bold, for example, for the big words that are really getting you on your nerves and you're not sure what to do about them. You can even add a bit of code in there just to make sure that it's very clear and concise, and I can look through it and maybe even copy it and try it on my own project and see where the problem is. You can add screenshots for the different errors that you might be getting, or what's different from the videos that I'm teaching you and from what you're getting on your own screen, because that can happen sometimes depending on the version that you're using and so on. You can also add maybe a italic word. And another thing that you can do, you can also go and edit your questions. So for example, let's say you've asked me a question and you found out a solution for it. You can go ahead and edit the question and put a solved under it. And what this solved does is it actually does two things. First of all, it allows other people in the community to know that this question, if they search for the question, they know that it has been solved and they can read the solution. And it also helps me to know what questions have not been solved yet and need further inspection and delving into. Great. So use the Q&A at your leisure. There is no bad questions. There are only bad students that don't have the courage to ask the question. It's not something bad to do. I do encourage you to go out and try to find the solution for yourself. But if you ever get stuck and you need help, don't be afraid to ask any kind of question that you want. Okay. Let's move on to the challenge slides. Now, what are the challenge slides? Well, these are slides that you are going to be encountering almost every single video. And this is your challenge slide. When you see this slide, you pause the video and do the challenge on it. So whenever you see this kind of slide show up, you can see that it has a main title, for example, the Download Unity and Visual Studio, and then it will have a couple of instructions for you to follow, and sometimes I also give you a couple of hints to try and do them by yourself. So whenever you see this slide, you see this pause, big red pause button, you need to pause the video and then go try and do whatever the challenge tells you. And why are we doing this type of challenges every single video? Well, because personally, me, Michael, I've went through a lot of courses, a ton of courses. The problem is that I always see is that the instructors go through the motion and they keep talking and doing and talking and doing, and you follow along, and by the end of the course you have a very good game and it's working and everything is fine. But what I found is that in the long term I actually haven't learned how to do anything. I just learned how things are done. There is nothing for me to, there was no incentive or nothing very concrete that I've learned from these courses. So this is what I wanted to do. It's a much better way to learn when you pause the video and you actually go out of your way to do the challenges. Even if you have no idea how to do the challenge, you need to pause the video and at least give it 5 to 10 minutes to try everything in your power to do that. Because doing is always better than watching. So let's say you get a challenge, you have no idea how to do it, you try your best, it doesn't work. And then you can continue the video, you see how I do the challenge, how I complete it, and it will be ingrained in your mind forever. whenever you try something and you fail at it, you then have a much better chance of learning after you've tried. So I encourage you to always pause the video, always take the time, even if it seems impossible and you have no idea how to do it. Maybe search online, do your best, try to do the challenge. And usually whatever the challenge is, I usually do something in a previous video, and then a couple of videos later I do the challenge. I give you the challenge to do something that we've already covered, so it's never going to be something outside of your boundaries of learning. Okay, great. So let's talk about the course structure. So in section 1, which we are currently on, we are going to do a bit of introduction. So we'll talk about how to learn from this course, we'll download Unity and set up with Visual Studio, and we're going to be setting up our world. We'll also learn about a very powerful tool, which is version control, that will allow us to set up everything, and it's a tool that is used by very professional developers, not only game developers, but any kind of programming developers. So if you already have Unity and you already know what Visual Studio is and you have version control set up, then I recommend that you move to the last video in this section, which is the setting up, where we will set up our world, and then you can move on to the next section. Section 2 is where we are actually going to start building our Cyber Spy 2087 game. And we're going to start off by adding our player. We'll be setting up the character controller that will allow us to move. We are going to start moving our player from the inputs of the person that is playing our game. We are going to take our first step, and we are going to set up the first person camera on top of our head. So we'll begin to move with our mouse, looking around with the camera and moving our entire player body. It will be a small capsule around our game. Next thing, we'll start with the section 3, where we'll introduce shooting into our game. We're going to create bullets, we'll be firing these bullets, and we're going to create a way to actually point our bullets to a certain location that we are looking at using something called a raycast, which is going to be very exciting. We'll also create a couple of enemies that we can shoot down. Next thing, we'll move on to section 4, which is advanced moving. And this is where we'll be adding gravity, we'll be jumping, sprinting, crouching, and sliding our way into destroying all of our enemies. Next, we have section 5, which is advanced shooting, and this is where we're going to create a gun system. Now, in the normal part of shooting, we're simply going to have a small block, but in advanced shooting, we are going to have multiple weapons, like a pistol, a very advanced and good-looking pistol. We'll add ammunition to our game, and we are going to create ways to aim down our sight. Next thing, we have the enemies, because of course now we have an amazing movement, we have amazing shooting, but we don't have any smart enemies to shoot at. And this is where the section 6 comes in, and it's about animating our enemies. We'll create AI for our enemies that will chase us if we get close, and if they catch us, they will start attacking us. And then we move on to section 7, which is the health system. Because currently, at this point in our game, we have enemies, we can shoot them, they can hurt us. Well, actually, they can hit us, but they cannot actually hurt us, and we cannot hurt them. And this is where the health system section comes in, and we'll add a health system to the enemy, and we'll add a health system to our player. But not only that, we are also going to be displaying these health systems using a health bar, one for us and one for the enemies on top of them. We'll also learn how we can actually respawn our player whenever he dies. We then move on to weapon system in section 8, and it's where we're going to be adding more weapons. We'll be picking up more weapons, and we are going to add a rocket launcher to our game. We'll also add a mechanism for reloading and animations for reloading all of that. We'll also create a system for picking up health and ammunition as we go through our game. Section 9 is the very exciting part because this is where our game will come to life. We'll add audio in the background. We'll add audio to our guns, and we are going to create a very good menu that looks amazing. We'll also learn how to create pause menus and all of that. And we move on to section 10, where we'll need to create a world for our player to kill monsters in. So we'll be adding world assets. We'll add different ways that we can actually make our game look much better using post-processing. We'll also learn about how lighting in Unity works, and we'll learn how we can transition between different levels when we get to a certain point in our game. And finally, we'll have the bonus section. And why did I call this bonus section? Well, because all the core game mechanics will be finished by section 10, and bonus section, which is a grappling hook, will allow us to, well, create a grappling hook that we can put onto the buildings, and then we zip to that point that we've chosen, and it's going to be very nice, it's going to be very cool, and it will really make you feel like you're Spider-Man. Anyways, as you saw, this course is packed with information. It has a lot of things to do. And before we start, I just wanted to say something, that if you put in the work into this course and you really give it your all, you will come out of it on the other side with incredible Unity and C# skills. And this is my goal. My goal is not just to sit here and create a game and let you watch it. You can do that anywhere you want. My goal is for you to end this course being a master problem solver. I want you to be able to create this game from scratch by your own. And this is why I urge you to put in 110% effort into every single video, and always make sure to do your best with the challenges. Never shy away from asking me questions, but also try to figure out things for yourself. And if you can't find out how to do it, or something is a bit too complicated for you, never hesitate to go into the Q&A and ask me any questions that you want. Udemy is going to ask you for a review right now, so I would really appreciate it if you like me as an instructor and you already kind of feel that this course is going to be amazing. Leave me a review, I would really appreciate it. Or if you want to go through a couple of videos and then make that judgment later on, I also have no problem with that. With that said, I hope you enjoyed this little video where I talk about the course, and in the next video we'll start downloading Unity and integrate it with Visual Studio. So I'll see you there. Welcome back, my fellow game developers. In this video we are going to be downloading Unity, installing it, and integrating with it the Visual Studio tool that we are going to need for this course. So let's get started. First thing, you'll need to go into Google, and in Google simply type in right here, download Unity. It's as simple as that. When you type in, you will get a lot of suggestions, so make sure that you find the one with the unity3d.com and the Get Unity, of course, and click on the Download Unity, which will open this page right here. So in here, you'll need to download Unity Hub if you have never before used Unity. Now, what is Unity Hub? Unity Hub is like a place where we will keep all of our versions of Unity and also all of the projects that we make. Now, before Unity Hub, our projects will be all over our computer, somewhere in different directories and so on. So Unity Hub really makes it much easier to go through your project and really have a really good organization. So make sure that you download Unity based on which operating system that you have. So if you have the Mac OS, you need to make sure that you download the Unity for the Mac OS. And if you have a Windows 7, then you download it for Windows 7. So simply click on Download Unity Hub, and when you finish downloading, you should have this installation folder right here. When you double click on it, it will ask, do you want to? Yes. So you continue on, you click on Agree, you choose the destination where you want to put your Unity Hub, and then you start the installation. Now, because I already have Unity Hub installed, I will not install it again. So make sure that you install everything, and I'll see you in just a bit. Okay, welcome back. So if you've installed Unity Hub correctly, you should get a message or a window right here that looks something like that. Now, we don't have any projects yet, but this is where our projects will all be present and we can access them at our leisure. Now, before you continue on, Unity will have to make sure that you have an account. So this is my account right here. I used my Google Gmail to create an account on Unity. You can either create a new account or you can also use your Gmail or Facebook. I'm not sure if they allow that. And once you've created a account on Unity, you can go right here into the installs, and this is where we download different versions of Unity. Now, for this course, I'll be using the latest version of Unity that we currently have. Now, if you want to install a new version of Unity or any kind of version of Unity, simply go right here into the Add, click on Add, and in here you can see that we have different types of Unity that we can install. Now, first of all, we have the recommended releases. These are the ones that have already been tested and thoroughly tested and they work perfectly, but you can also go and look for the official releases. Now, we are going to be using this version right here, and this is a very good version. You can install it, and you also have the pre-releases. Now, pre-releases do work the same as the official releases and the recommended releases, but they are sometimes a bit buggy and you may encounter a couple of bugs. Now, on the official releases, there also might be a bit of bugging issue, but they are not as evident as in the pre-releases. You may not encounter any problem, but I would recommend that you use the official releases because they are newer than the recommended releases and less buggy than the pre-releases. So download the latest version that you have on your computer, or currently maybe you are from the future and you have a newer version than me, so download the latest version. And don't worry, this course works, or the project that we are going to create will work on any version of Unity in the future. Now we are going to click on next right here, and this is a very important part of downloading and installing Unity. Now in here we have modules, and these modules are like add-ons to our Unity that allow us to create games on different platforms. So for example, in here you can see that we can download modules for different platforms. So for example, if you want to create a game on Android, you can use the module for Android. Or if you want to create a game for the iOS or the iPhones and so on. You may also be looking to create games for Linux or Mac OS or WebGL. So based on what you want to create, you can choose one of these modules, or you can just wait later on. You can download these at any point. You also have the documentations, which I recommend you download. These documentations are the Unity documentations, and they are very important. Maybe sometimes you want to look up certain things. And finally, you have the language pack, and maybe if you're Chinese or Korean, I'm not sure what these are, honestly. I have no idea. Maybe you can use one of these language packs. But the most important thing, and you need to make sure that you have the Microsoft Visual Studio Community 2019 or newer installed with your Unity, because we are going to be using Visual Studio to code everything and all the behaviors of the objects that we create in Unity. Now, this is all you need to do. Simply click on next and you will begin the installation of your Unity. So with that said, it's time for your first challenge. And your challenge is going to be to download Unity and Visual Studio. So download Unity Hub just like I showed you. Make sure that if you have a Mac, you download the Mac version. If you have a Windows, you download the Windows version. Then you need to download Unity's latest release. And finally, make sure that you also download Visual Studio with Unity. So pause the video right now and go ahead and download Unity with Visual Studio. And in the next video, we'll simply go over the interface of Unity and Visual Studio just so we can get over our initial fears. So I'll see you in the next one. Hello and welcome back, my fellow game developers. In this video, we are simply going to be explaining what Unity is, what Visual Studio is, how they communicate with each other, and we'll explain a little bit about the interface of both these amazing tools. So, first of all, what is Unity? Let me put on my laser. So, laser please. Okay. So Unity is a cross-platform game engine developed by Unity Technologies. So what do I mean by cross-platform? Cross-platform means that it can be used on different kinds of platforms, like for example Unity, Windows, and Mac OS. We'll be using Unity to develop our games, and we of course going to be using this Unity engine right here. So, before we move on, let me just show you the interface of Unity and we will move on to explaining Visual Studio. And this is Unity. Congratulations, you've made it this far. So, first of all, we have our toolbar right here above everything. And this toolbar provides access to the most essential working features. On the left, we have the basic tools for manipulating the scene view and the game objects within it. In the center, we have the play and pause and step control right here, which allows us to play our game, pause our game, and then we can also add a step frame by frame. The buttons on the right give you access to Unity Collaborate and the cloud, which we'll not be using, and the accounts. We also have the layers right here that we will be using a lot in this course for our project, and we finally have the layout. And by layout, this is our layout right here, so we can change the layout, for example the 2x3 or the 4 split, or we can basically use the default, and this is what we are going to be using. So if you don't have the same interface as me or different kinds of layouts, simply click on here, go to default, and we will both have the same interface. Now, next thing I want to talk about is the hierarchy window right here. So if we click on this right here, we can see that we have a main camera, and this is our scene view. We'll get to our scene view, and we have the directional light right here. But this hierarchy right here represents every game object in our scene. So each item in the scene has an entry in the hierarchy. So the two windows are inherently linked. The hierarchy reveals the structure of how game objects attach to each other, and you will see in more detail what I mean by attached to each other. Now, next thing, we have the scene view right here, and if we right click on our mouse button, we can actually move around using the WSD keys right here, and you can see that we can move around our world, and in here we are going to be building our games. We also have another window right here that is the game, and this is our game view. So this is how we see our game from the camera's perspective. We'll be changing everything around, and this is where we are going to be most focused on later on with our game creation. Next thing, we have the inspector window on the right. Let me go back to the scenes. So in the inspector window, you are allowed to view and edit all the properties of the currently selected game object. So as you can see right now, we have the directional light selected. We can increase and decrease the intensity. We can change the color. We can play around with everything. And we also have the main camera right here. We can also change and play around with various properties in the inspector right here. And these technical words are very important because I will be using them throughout the course. So remember, hierarchy, inspector, the scene view, the game view, and finally we have the project window right here. And this is where we display the libraries and assets of our game. So if we click on assets, currently we have nothing else besides the scenes, and if we double click on scenes, we have the sample scene right here that we can double click and enter, we can save. So we don't have anything besides our scenes. Next, let's talk about Visual Studio and what it is. Okay, so what is Visual Studio? So Visual Studio is actually Microsoft Visual Studio, and it's an IDE. What is an IDE? It's an integrated development environment. And what that means is that it's like an environment for us to develop integrated code into Unity. So this is a very complicated explanation, but this basically is where we are going to write all of our code, and VS will help us write the code used to manipulate game objects in Unity using scripts. So what are scripts? This is the way we use Unity with Visual Studio. So we want Unity to communicate with Visual Studio. In Unity, we are going to be creating game objects. So for example, the car that we want to move. Well, not car, the player that we want to move around. The maybe objects that fall down, maybe the weapons that shoot, the monsters that attack us. We put all of these objects in Unity, but whenever we want to manipulate them, we are going to use Visual Studio. But Unity and Visual Studio don't automatically work together. The way we make them work together is through these scripts, which are .cs files, and this is where we write all of our codes in the .cs files in Visual Studio, and from these scripts we are going to manipulate the behaviors of the objects that we have inside of Unity. So let me just show you how Visual Studio looks. So this is Visual Studio. Let me just zoom in a bit, and in here you can see that first of all we have these three lines which are using something, and using Unity's engine. Now these are called namespaces, and what these are, they are a collection or a library of codes that allow us to use certain things in our game. So for example, the Unity engine allows us to use different aspects of Unity. For example, the physics in Unity, it allows us to access various details in Unity that without this, so for example, if we remove this line right here, we can no longer use monobehavior, and because we are not using monobehavior, which we'll get to in a second, we can no longer use start and update. So we'll turn this back on and we can use monobehavior. Before we get to that, let's first talk about what public means. Public means that it's for everybody. There are two types. There are public and there are private. We'll get to that also later on. We have the class and we have the class name. And this is actually the name of our script, and we will learn that we have to always make sure that we name our class correctly the first time. Because it will create a lot of problems for us. So this is how we create a class, and all of this code will be written automatically, so you don't have to worry about it. These 2 points right here means that we are inheriting mono behavior. So what is mono behavior? Mono behavior are, well, we use behaviors that are already built into Unity that allow us to control the various game objects. And because of mono behavior, we can use two methods or functions, which of course we'll be later on getting into, like start and update. And actually in here you can see that we have this green line, and this green line means that this is a comment. And whenever you want to create a comment, you simply put these two backslashes behind it. And whenever we put two backslashes behind any code, it means that this is a comment and it will not be executed in code. Great. So what is start? Start is called before the first frame update. So whenever the game object that has this script attached to it starts, the code inside of the start method will be executed. And similar to start update is called once per frame. So every frame our game goes through, this method update will be called and everything inside of it will be executed. To put it more simply, start is where we put our initial conditions. So for example, the weight of the car, the speed of our player, the climate maybe. And an update is where we make our car move, we make our player jump, and we make the climate change, for example, the wind blows up or something. I don't know. So this is how we basically use Unity with Visual Studio. Of course, in the future, as we move through our project, you will have a much better understanding of the start and update and everything in it. So don't be worried too much if you don't understand everything right away. But now you have a challenge in front of you, and your challenge is going to go and make a mess. So open Unity and mess around, click on a few things, and when you're finished, go to the next video and we are going to be making our first code and get started. And if you still don't know how to create a new project, don't worry about it. In the next video, we are going to create a project and make our first code. So I hope you enjoyed this video and I'll see you in the next one. Welcome back, my fellow game developers. In this video, we are going to be creating our first game object, creating our first code in C#. And as you can see right here, we learn how to clear things, we learn how to collapse stuff. When we hit play, we can see that we get one message that is hello Michael, your name will be here, and below it we have hello Michael a lot of times, and as you can see we have this once, and here we have it incrementing until infinity. So let's not waste any more time and let's get started. Okay, so let's get started. First thing we're going to do is we're going to open up our Unity Hub right here, and we're going to click on a new. Now in here we are going to start creating our project. We can choose the 2D template, we can choose the 3D template, we can choose the high definition RP, and this is where we create games with much higher graphics, and the universal render pipeline or URP, where we create good graphics but not as high definition as RP. So for example, high definition RP are for like AAA games, and the URP are like for, let's say, advanced indie games. But for now we're simply going to choose 3D. You're going to choose the location, for example, in here. So the location, it will depend on you where you want to put your project. And in the project name, we are going to name this as our first project, the Hello World. So click on create, and now we are going to wait for Unity to create our project. I will use the magic of editing in order to move past through this long process, and I'll see you on the other side. Okay, so welcome back. I hope your project creation is finished, and if your layout is not similar to mine, you can click on layouts right here and choose default, and we will both have the same layout. Great. So first thing first, we are going to, well, the whole point of this video is that we are going to be creating a object that will have a script on it, and this object that has a script on it will put something to the console right here. And if you don't have console, you can go to window, go here to general, and you can see that somewhere in here we have the console right here. So window, general, and a console. Click on it, you will have a window around here, so it will probably be like this. You can actually choose to dock it wherever you want. So we can dock it right here next to games, but I prefer to dock it right here next to projects. Great. Now, first thing, what are we going to do? We are going to create a game object. And it's very simple. We simply go to our hierarchy, we right click, and in here we can choose what type of object we want to create. We can create 3D objects that we'll do later on. We can create effects, we can create light, we can add audio, we can add video, we can add UI, which are the canvas, and so on and so forth. But for now, we're simply going to create an empty game object that we are going to call Hello World Printer. Great. So as you can see right now, we have this game object, and if the way we move around this world is, as I've told you, right click and move with the WASD. And as you can see, this game object is empty. It doesn't have anything. It only has these 3 arrows right here pointing out. And if we look to the upper right corner, we can see that the blue one is the Z axis, the green one is the Y axis, and the X is the red axis right here. And as you can see on the right, we have this transform right here. And if we move on the X axis, you can see that the X increases. If we move back, it becomes negative. And this is the position of our game object. Now, if we go up here in the toolbar, we can actually choose the rotate tool, or we have a much smarter way of doing things is by clicking the E key. So when we click the E key, we automatically go to the rotating tool. And if we hit the red, we rotate around the X axis. So now if we rotate backwards, you can see that the rotation angle changes. We can also rotate down, and our X rotation is positive. We can also rotate on the Y axis. We can also rotate on the Z axis. And finally, we have the scale, but for now, we will not be changing around the scale. It will not be as noticeable as with different objects. So for example, let's say you've created a mess right here and you move the object somewhere very far away, and you want to actually make the, well, reset the position, the rotation, and the scale. We can go in here into the transform. We have these 3 little buttons right here, and if we click on it, we can actually reset the entire game object to the 0, 0, 0 position and 0, 0, 0 rotation. Okay, great. And in here, as you can see, it disappeared somewhere. Why is that? Well, because we are not selecting it in the hierarchy. So if we click on the main camera, this is our camera, and this is what we see whenever we click on the play button right here. So in game, if we click on game, we can see that this is what our camera currently sees. So back in scene, we can move this up, we can rotate this also down and up, and in here you can see the game view. So if we move it down and keep just a little bit of white up here, in game mode we can see that it's exactly the same. Now let's put this back, and we actually are not going to reset. I'm using Ctrl Z to go back from all of the things that we chose. And we also have the directional light, which we'll not be using currently. So back in Hello World Printer, if we click on the W, we go back to changing the position. Now, what are we going to do? We are going to be creating a script in which we are going to be printing things out to our console. So down here, inside of our assets, we are going to right click, we are going to go to create, and in here we have the option to create a C# script. Let's click on that and stop everything that you are doing. Do not touch anything. Don't click anywhere. This is a very important part of creating any script, even when you become a professional game developer. You need to make sure that you know what your script is going to be called, because if you want to change it later on, it's going to be a pain in the butt. So we are going to make sure that we name our script correctly the first time. So back in here, we are going to click on backspace to remove everything, and we are going to call this Hello World with a capital H and a capital W. So hit enter, and as you can see in here in the inspector, the code compiles, and when we double click on Hello World, it opens up in Visual Studio. Okay, so now we are ready to start coding. So as you can see, what we named our script is actually our class name. So why did I emphasize the point of naming our script correctly? Because if you want to change the name of your script, you'll have to change the name of your class, and there are also going to be a lot of other errors that you'll need to address before you continue. Okay, great. So now what are we going to do? Well, we want to simply print something to our console. And the way we print something is we'll go into start right here and we'll simply write print. And as you can see, Visual Studio immediately starts helping us. So it notices that we are writing something that is similar to print, so it gives us this suggestion. And not only that, it gives us an explanation to what this print actually does. So in here, it logs messages to the Unity console, identical to debug.log, which we'll be using later on. But for now, we'll simply use the print. So when you get to this point and you choose one of the options that Visual Studio gives you, you can simply click on tab and it will continue on its own. We'll open these two bracelets or brackets right here, and we are going to put these two quotations inside. And in here we are going to write hello world with an exclamation mark. And now, as you can see, there is something wrong. First of all, we have this X right here with one error, and we have this little squiggly red line. And if we hover over it, we can see that it tells us that there is an error and it expects a semicolon at the end. So let's add this semicolon. And now you can see that whenever Visual Studio finds an error in your code, it will actually tell you about it. So as you can see right now, when we added the semicolon, all the errors have been saved, or all the errors have been removed. And finally, we need to save the script. And this is extremely important. If you look up here, you can see that there is a small asterisk next to our hello world.cs. And when this asterisk means that we have not yet saved our script. So to save that, we can either go to file and click on save like our grandpas used to do, or we can simply hold Ctrl S and we save our script. Anyways, now that we've saved our script, we go into Unity, and now we should see here that we have no error. And if we click on play right here, well, as you can see, nothing happens. So what's the problem? Did your instructor make a mistake? Did we do something wrong in Visual Studio? Well, actually, no. The problem here is that we haven't actually attached this script to anything. And trust me, this is a very common mistake. So let's attach our script to our Hello World printer. So we simply drag Hello World into the game object in the hierarchy, and in the inspector you can see that it has been added. Or we can also take this Hello World script and drag it into the inspector of our Hello World printer object, and we'll add it right here. But now we have two scripts right here, and we can simply remove one of them by clicking on the three buttons and hit the remove component. Great. As you can see, the scene is not yet saved. It has an asterisk next to it. So click on Ctrl S, it has been saved. And now when we click on play, we should be able to see right here, Hello World. It's in a message right here under the assets, projects. And here you can see that we have Hello World printed. Great. This is very fun. Now, next thing I want to show you. In here, let's simply make this a comment. This means that it will not be executed during code. And let's actually print right here, print Hello World in update. And let's see what this does. So let's save that and make sure that you have the semicolon, you have this saved, and it's inside of update, which is called once per frame. If we go back into our game, I want to show you something in here. in the hello world has been printed, and if we look to the right, you can see that it has been printed once. So one time it has been printed. Let's click, if you have collapsed right here, simply unclick it, make sure that its colors are the same as the other tabs right here, and let's hit play. So as you can see, Hello World in update is being printed every single frame that we play our game. And this is the difference between the start, which only prints once the game has started, and the update which prints something every frame in our game. So great, let's stop this right now, and as you can see, we have a ton and ton of messages right here. So I hope you enjoyed and I hope you understood everything, because now it's time for your challenge. And your challenge is going to be to print your own name. So instead of hello world, you are going to be printing your own name. So change hello world to hello, and of course your name instead of these points. And I'll give you a couple of hints, even if this task is very easy. Maybe some of you are just starting out with coding. So add your own name inside of the 3 points right here and save in Visual Studio. Go to Unity and click on play. Don't forget to save inside of Visual Studio and check your console. And you can either put this message inside of start, or you can put it inside of the update just to play around and see how all of that works and feels. So pause the video right now and go do the challenge. Okay, welcome back. So how did you get on with that? Let's go into our script right here. Let's remove the comment, and instead of hello world, we are going to write, well, actually I'm going to write, hello Michael from Double M Game Dev. And inside of update, we are actually going to write hello Michael a lot of times with an exclamation mark, and let's remove the update, and we have an asterisk. That means we haven't saved, so let's save that. And back in Unity, if we hit play, we will see, and if in here actually let's do something. If we hit pause, you can see that the game stops, everything stops, and now every time we hit play, when we hit the step button, you can see that we have a new message and a new message and a new message, and it actually gives us the timeline. So now that we've waited a couple of seconds, this should be maybe 18. So whoa, that was so accurate. Nice. So as you can see, every single step means every single frame, and that means every single frame that we go through, update prints something to the console. And if we hold our cursor right here and we move up, we can see that the first message, which is inside of start, was hello Michael from Double M Game Dev, which was the line of code inside of start. And one final thing I wanted to show you is the collapse button right here. We can actually clear all of our messages, and we can actually clear on play. So let's clear all of our messages and hit the collapse, and if you hover over it, you can see that it collapses identical entries. Click on that, hit play, and as you can see, hello Michael from Double M Game Dev shows up in the beginning, and then you have hello Michael a lot of times that prints, well, a lot of times. And because we've hit collapse and these are all identical, they are on the same line. So let's stop this right now. I hope you enjoyed the video. In the next video, we'll talk about version control and how we use source tree, a very powerful tool for advanced game developers and advanced programmers overall. So I'll see you in the next one. Welcome back, my fellow game developers. In this video, we are going to be learning everything about version control, source tree, and creating repositories of our projects. So as you can see right here, we've created a new project. We started our big project, which is CyberSpy 2087, and we've downloaded source tree. We now have a couple of commits in here, and we actually reverted something. We've created our initial commit, added a cube, reverted it. We can actually reverse this commit again. So click on yes. As you can see, we can go back to Unity, reload, and we have our cube right here. We will be learning everything in minute detail. So give me your entire concentration. This is very important. It's an extremely helpful video or lesson, and it will stay with you forever as long as you are committed to becoming a professional programmer or game developer. So let's not waste any more time and let's get started. Okay, so version control. Let me put on my laser. Version control, it's hard to learn, it's even harder to teach, but I'll try to keep it as simple as possible. And when you get the hang of it, trust me, it's very simple and easy to use. Plus, it's an indispensable skill that you need to learn if you are looking to become a professional game developer or even a professional programmer. So let's get started with what is it. First of all, it's a system that is responsible for managing changes to computer programs. So this means that whenever we create changes in our programs, we can actually save those changes at each step of our project. This way, we can first of all check what we did. We can create different kinds of versions where we can go back and change the things that we've created. It allows for a better teamwork. So for example, let's say you have 4 or 5 people working on the same project, but each one of them has a different task that they need to create. So version control is a very good way of handling all of this. And why do we need it? Well, why we actually use it? Well, we'll use it to remember previous version of our game and have more flexibility to experiment. Usually game development is an environment where you require a lot of experimentations. For example, you want to add some kind of property to some kind of game object and maybe it breaks your entire project. So you want to always have a previous version of your project before adding this game-breaking mechanic, so you can always go back and start fresh from there. So this is extremely important, especially for game developers that always need to be experimenting with new ideas and things in their games and projects. And how are we going to use it? Well, we are going to be using something called source tree. And this is version control. It allows us to create different versions, and it's, first of all, it's for free. It's very easy for beginners, very flexible, and it has a very simple interface that we can use as beginners. So let's go ahead and download source tree. Let me show you where we can do that. If you open up Google, Chrome, or any browser that you have, simply go to Google and write in here download source tree. You should find a link right here, and it should be the source tree app. When you click on it, you go right here to their website. If you scroll up, you can see that you have the option to download for Windows, but if you are on a Mac, make sure that you click on here and you download the source tree for Mac OS, or it will not work for you. So if you have a Mac, download the Mac version. If you have a Windows, download the Windows version. Simple enough. Now, when you finish downloading, you should get this file right here. And when you double click on it, you should start the installation. Now, because I already have source tree, I will not be installing it another time. I will just take you through the process of actually installing it. Okay, so this is the first window that will pop up for you. First of all, you'll need to agree to the license, of course, and you can maybe turn this off if you don't want any emails your way from source tree and etc. Atlassian. Next thing, you'll need to do is you need to create an account on Atlassian. You can go to Atlassian, and Atlassian is the parent company of SourceTree. You can go ahead and create an account there, or you can use an existing account if you already have a Gmail. I personally created one using Gmail. It's much faster, it's way easier, and they don't spam you with a lot of emails. Next thing in here, we are going to connect it to an account. Now this is, of course, we will not be doing this. This is if you want to host your code on a certain website like GitHub or Bitbucket. We will not be doing that, so you can simply click here on skip setup. Finally, while installing, SourceTree will tell you that it is unable to locate Git. So in order to complete this, simply click on download an embedded version of Git and continue on. And then it may also ask you for something called a Mercurial. Now, Mercurial is a different system, just like Git. It allows us to save different versions of our project. We will not be using Mercurial, so you can simply click on I don't want to download, or I don't want to use Mercurial, and this should be it. When you finish installing, you should have this right here in your, this window right here when you start SourceTree. If you don't, simply click right here on create and you should get this window. Now this is where we actually create our repository, and in here you can see that we have the destination path, the name, and the type of version control that we want to use. Of course, we'll be using the Git. We also have the option to create an account, but as I've told you, we're keeping things very simple. It's our first time, so we will not be creating any account. So in here, we are going to choose what is the destination path of our repository. So what is the project that we are actually going to be creating a repository for and subsequent versions of? Well, let's create our first project that we are going to be using. So in here, let's open up the Unity Hub. And as you can see, we already have Hello World that we've done in a previous video. Let's click on New, and let's make sure it's a 3D project. And this is going to be our Cyber Spy 2087. Let's go ahead and create this project. So click on Create. And I, of course, always using my magic of editing in order to speed up this process. I'll see you on the other side. Okay, welcome back. So I hope everything worked out for you. So now we have a new project, which is Cyber Spy 2087. So now that we have our project created, we can actually go ahead and get started with creating a repository. Now, if we go back into our SourceTree right here, we can click on Browse, and we can actually go ahead into Unity projects, and you can see that we have a Hello World and we have a Cyber Spy 2087. So let's select this folder. It will create a repository under this name, and if we hit create, it will ask a problem. Don't worry about it. Click on yes, and voila. Now we have actually started creating a repository. You have the staged files right here. You have different kind of knobs. You don't need to worry about any of them. For now, just focus on the staged files, unstaged files, and commit up here. Now, if we scroll down in these unstaged files, you can see that most of them are from the library. We scroll down to the end, we can see some of them are temp or temporary. We can see also that we have project settings, and these are all the files that we have for our project. We also have assets in here for Unity in the scenes, for example. So this is a repository, which is a version of our current project. Now, the problem here is, as you can see, there are a ton and ton of files, and we will not be needing all of them. Well, actually, we'll need almost none of them. We will need only a certain kind of files. So we want to be ignoring the library and the temporary files. Why is that? Well, let me show you by opening up the directory of our current project. Okay, so this is CyberSpy 2087's directory inside of Unity project, as you can see up here. So we have the assets, the library, logs, packages, etc. and etc. Now, what is the temporary folder and what is the library folder, and why don't we actually need them? So temporary is just a way for Unity to open up faster whenever we start the project, and it's always created whenever we open a project. So for example, if I go into Unity right here and I actually close it, you'll see that the temporary file will disappear. And even if we delete the library right now, so let's go ahead and delete this library entirely. If we go back into our Unity Hub and open up CyberSpy 2087, as you can see right here, you saw that the library has been created again and the temporary folder has also been created. So, of course, the project should take a bit more time now to open up, but this is evidence that a library and the temporary folders are not necessary for us to always commit and stage. And what do I mean by stage? So, whenever we stage our folders, we actually create a commit from them and a version of them, and library takes up a lot of space. As you can see, if we scroll down, it takes up most of the space and we don't want any of them at all. So how should we proceed? Well, we can actually ignore all of the folders that are under the library by simply going and choosing any of the folders that have library on them, right click on it, and in here you can see that we have the option to ignore one of them. So click on ignore, and in here you have the option to ignore this exact file name, ignore all files with this extension, or you can ignore everything beneath a library, and this is what we want. So click on OK, and as you can see, everything under library has now been ignored, so we cannot stage it, so we cannot save it to our newer version. And if you scroll up, you might have noticed that we have a new folder in here that is the .gitignore, and when we click on it, on the right you can see that it has the library in it. And if we double click on it, we can actually open it up in our notepad, and in here we can add the different files that we also want to ignore. So what are the files that we want to ignore? Well, there are a ton of files, but thankfully somebody has actually gone through all these files and created a list of everything that we can ignore whenever creating version controls or versions of our project. And in order to find that file, you can go again into Google, our dear friend. Go ahead and search .gitignore Unity, and you should have this link right here for the github.com. It will be hosted on GitHub. If you open up this link, it will take you right here. So this is the .gitignore, and it's the unity.gitignore, and these are all the files that we can ignore when creating versions of our project. You can click on raw right here, and it will open up this window or this tab. Let's go ahead and select all of them by clicking on Ctrl A. We will copy all of this using Ctrl C, and we are going to paste it in here in our .gitignore notepad. And now we have this gitignore notepad filled with all the files that we will not use for our repository. We will save that using Ctrl S. And now back in Unity, or I mean back in source tree, you can see that when we hit the gitignore, everything is ignored. We will stage all of that. And when we stage all of that, you can see that these are the files that are going to be committed, and these will be our initial commitment or our initial repository version of the project. And usually whenever you create your initial commit, we call this the initial, you can capitalize it, the initial, initial commit. and we click on commit right here. So now if you look on the left, you can see that we have branches under here and we have the master branch. Congratulations, we have created our first commitment. Very nice. Now let me just show you how we will move further down the line. Even though this video has been long enough, but I think we need to get a proper foundation for source tree and version control as we move through our project. So let's say we are in our project right here, and let's go ahead and create some kind of cube. So 3D object, right click in the hierarchy, 3D object, create a cube, and now we have a cube. Let's scale it up a bit, so scale it on the X, the Y, and the Z. Great, so now we have a cube in our scene. And now if we go into source tree, let's save that before we go, and it needs to save it to a certain scene. So let's, inside of scenes, this will be our sample scene. Sure, sample scene, yes, replace it. So we have this sample scene back in source tree. Wait for it a bit, and you can see that we have uncommitted changes. So if we click on them, you can see that the unstaged files are changes inside of the scenes, which is the sample scene. And here you can look in detail what we've created. Now, it's a bit weird right here, but if you look closely, you can see that we've created box collider, and basically this represents the cube that we've added to our scene. So let's go ahead and stage all of that. We can click on commit right here and name this added a cube. Click on commit, and now in our master branch you can see that we have an initial commit which didn't have any cube, and now in our added cube we've added a cube. So congratulations. And as a final note, this may look a bit cumbersome, this may look a bit weird, but don't be afraid. This is very simple, and more importantly, it's extremely important for us to understand as we move through our project, create versions of it. And if we ever make a mistake, we can actually go back by right-clicking in here and reversing the commit. And yes, we can reverse the commit. If we go back into Unity, it will ask us for a reload. We reload, and now we don't have the cube or any game-breaking mechanic that we've added along the way. And now it's time for your challenge. And your challenge is going to be to download and set up source tree and the .ignore file. So download source tree, install and set up everything, create your 3D project in Unity Hub, set up a repository for it in source tree, ignore the library files, get the .ignore file and add it to your repository, create your first commit, and then create your second commit. You can even go ahead and try to maybe play around with a couple of things, add a cube, reverse the commit, see what happens, get comfortable with source tree. And if you're having a bit of trouble, you can pause the video on this list of things that you need to create. And you can also always go back and watch the video and see how I made everything and follow along with me step by step. So I'll see you in just a bit. So in the next video, we are going to be setting up our world, creating various materials, and starting our big CyberSpy 2087 project. So I'll see you there. Welcome back, my fellow game developers. As you can see, we've created an amazing plane right here. We've added a couple of cubes right here. We've added rotation to them. We've added scale. We've played around with the directional light. We've played around with the main camera. We've added this lighting and generated light. Very nice. This is a very cool video because it's the essence of where we are going to start creating and building our incredible game. And before we go, I forgot to do this at the end of the video, but make sure that when you finish this video and finish the challenge, stage all your files and commit them, and we'll call this creating our our playground. Commit that. In master branch, we have creating our playground. Great. So let's not waste any more time and let's get started. Okay, so first thing we want to do is we actually want to go into the game window right here, and if you look right under it, you can see that it's currently at free aspect, and we don't want that. We actually want to change this and make it 1920 by 1080. So this is the regular screen of anyone who is playing a game on the PC. If you don't have this option, you can add it from here and choose the fixed resolution, then make this 1920 by 1080. Okay, so let's choose this one, and this is how we are going to use our game. Great. Now that we have that set up, let's start off by creating our environment. Let's delete this cube right here. Right click in the hierarchy, choose 3D object and create a plane. So this will be our plane right here, and let's reset its position to be at 0, 0, 0. Great. So now the position is at 0, 0 and 0. Let's scale this up. I think we'll scale this up to 5 by 5, not the Y, sorry, the Z, 5 by 5 by 5. And because this is a plane, so as you can see, because this is strictly a plane, when we increase or decrease, well, actually decreasing makes it disappear, but even if we increase the Y to 50, the depth of the plane doesn't change, it stays the same. So let's keep it at 1. Great. And if you look here on the plane, we have the mesh filter. So the mesh filter is what gives the object that we've created a shape. If we change the mesh filter, for example, to a cube, you can see that the shape actually changes. And these green lines are actually called the collider that we have on our object. So this is the collider right here, the mesh collider of our plane. If we turn off this component, you can see that the green lines disappear, and then they reappear when we turn this back on. And basically, we'll learn more about colliders later on as we go throughout the course, but for now, just know that colliders allow objects to interact with each other. So let's change this to a plane, and the mesh renderer is actually the color that we have on our objects. So later on in this video, we are going to be creating our own material, but in here you can see that we have materials, and we can change it to, for example, the sky material or the default material, or this space, I'm not sure what this is, or flame or something, but for now we're just going to keep it at the default material that we already had. Okay, great. So now that we have our plane, it's time to create a couple of cubes. So let's right click in here and let's create a 3D object and create a cube. If you can see it, it should be right here under the plane. And let's zoom in just a bit. So in here we can move our object. If we click on one of the arrows, we can move them on these axes, or the axis that the arrow is in, or we can choose one of these planes. So if we choose this one, we can move it around on the X and Z positions. If we choose this one, we can move it around on the Y and Z. And if we click the E key, we go into the rotation tool, and we can actually rotate our cube. But one more thing that we didn't talk about is actually the scaling. So if we click on the R key, we can see that we can scale this cube in the Z direction, or in the Y direction, or the X direction. We can also scale it all over all the axes right here, and now we can scale up our cube and add it to our playground right here. So let's put this down right about, let's say, here, and let's scale it up just a little bit more. So now we have this cube right here in our plane, and just like the plane, the cube also has its own box collider and its own mesh renderer and mesh filter in the inspector. Great. Now let's go ahead and duplicate this cube, and put another cube right here, and maybe we'll scale it down. So basically right now we are creating some sort of playground to play around with. And we'll move this cube right here, put it down on the ground almost. And let's go ahead and create another cube and put it in here, and let's scale this cube up and make it sort of a tower-ish thing, and maybe add a bit of rotation and put it around here. Okay, and last thing I want to do, maybe let's duplicate this one also and put 2 cubes next to it. So these will be 2 cubes right here, and what I want to do in here is actually create a limbo. So if you know what limbo is, I'm not sure if it's even called limbo, and it's sort of like a small piece that will allow us to, just like this, so it's like a small rod that we can slide under or crouch under later on as we create movement for our player. Maybe we'll move this up or down depending on how much we want to crouch with our player. And finally, what else should we be adding? Well, let's go ahead and duplicate this again. And the way I'm duplicating them, by the way, I'm sorry, I'm actually clicking on one of our game objects and clicking on Ctrl D. So whenever I click Ctrl D, I duplicate the game object. And let's delete this one. Let me rotate this a bit. Let's duplicate it again. And let's move it a little bit in here. So currently our axes, as you can see, they rotate with our objects, and that's because up here on the left upper corner you can see that we've chosen the local scale. So if we click on this, you can see that it will go into the global scale and it will not change based on what the cubes are. So let's duplicate this again and rotate it once more, just a little bit, just to add a bit of variety to it. Duplicate that again, and let's rotate. So we have kind of this artistic looking corner over here, and we'll probably make the plane bigger later on. Finally, what I want to do is I want to add a ramp to this cube. Let's make this ramp, let's make this cube a bit bigger, and I want to add a ramp to it. So let's go ahead and duplicate this one, move it in here, and let's actually make this a bit smaller, make it this way. We'll rotate it upwards, or you know what, let me see how to make a ramp here. So this sort of looks like a ramp, sort of, kind of looks like a, is this a ramp? Does it touch the ground? No, it needs to be around here. So we'll need to make it a bit bigger. So while I'm doing this, I suggest that you also create your own playground with these essential things. So one big long tower that we can jump on, one little limbo right here, a couple of squares, and maybe this ramp right here, because we'll be using these all for different reasons. And actually I'm going to make my plane 10 by 10 because I want to have more space in my playground. So we'll move this up here, we'll move these up here, so move them there, we'll move this one around there, and these 4 cubes, oops, nope, not this one, not the plane, these 4 cubes I'm going to move to the corner right here. Okay, great. So now we have our playground, sort of, kind of, but the problem is, as you can see, they are all the same color and really bland. So what can we do about this? Well, we can create some materials. So if we go into project, let's right click in here and let's go ahead and create a folder, and this folder is going to be called the materials. And inside of this folder we are going to right click, go to create, and under here we can see that we have the option to create a material. So click on that. Let's go ahead and call this the cube mat, and this means the cube material. So let's go ahead in here. We can see that we can change a lot of things. We can change the albedo, the metallic, make it more metallic. And here you can see what the material is going to be looking like. So we can increase the smoothness or decrease it. We can make it more metallic. And we can change a lot of things. But for now, let's go ahead and click on here. And we can actually change the color of our material. So let's go ahead and make it orangey-ish like. And let's try that. So let's zoom in here. And the way we add materials to our game objects is actually super simple. We simply drag it over and put it on one of our game objects. So we can see that we can drag our material over game objects. And the cool thing about this is that when we now try to change our material, you can see that it directly changes on the game objects that we have applied the material to. So let's keep this at orangey-ish. And now, in order to make this a bit more, or add a bit more vibrance to these colors, let's go ahead and add emission to them. So when we click on emission, we can actually add another layer of colors to it. And let's go ahead and also make this orangey. So now you can see that they are a lot more vibrant, and you can choose to which degree you want this vibrancy to be. So as you can see now, these orange colors really stand out from everything else. So now that we have our orangey material, let's go ahead and add it to all of our cubes. And in here, you can actually do this to whatever you want. You can actually go ahead, for example, choose one of, this one is the cube 4. You can drag the material onto the cube 4, and we can drag the material on there. Nice. Now we want to create a material for our plane right here. So we duplicate the cube material, and we'll call it the, let's remove the 1, and we'll call it the plane material. And you can go ahead and choose whatever color you want with whatever emission you want. You can play around with this, but I'm just going to make it maybe green and change the, let's add this to the plane, and it looks very bad. Let's change the emission a bit and maybe make it a bit blue. Let's try blue. And nope, that's too much blue. Please let me move this. Maybe we should make it actually entirely black. We can also change it up. Oh, well, you know, black looks really nice actually. So let's move this just a little bit here. And now we have almost everything in our playground set up. Very cool. So now, one more thing I want to address is the shadows that we have on our current object. So as you can see, let me move this up just a little bit. So the shadows, wait, move this. I'm not liking this ramp a lot, so let me change this up a bit. Move it like this and maybe down a bit. Okay, so now let me change this to local, move it like this, and this seems to be good enough. Okay, great, I'm satisfied with it. So now, as you can see, well, actually you can't see because the shadows are gone, but they are very, very strong on our game objects. And why is that? Well, because we haven't actually generated any light to our scene. And the way we generate the light, if we go into window right here and we go into the rendering, we have this lighting option. So let's click on that, and we can actually go ahead and dock it next to our inspector. So in here we have a lot of options for the scene, environment, real-time light maps, and baked light maps. We are not going to go into detail right now in this video. Later on, we of course will be going through almost all of these and playing around with the lighting in our game. But for now, all you need to know is that we can actually generate light. So if we click on generate light and wait just a bit for it to create a global illumination, you can see that everything is much, much clearer. And now we can go into material and maybe change the colors based on So we can change based on what we have right now created, based on the baked aspects. And if we zoom in, we can see that the shadows are a bit lighter. So remember, window, rendering, lighting, and in lighting, simply click on generate lighting. Now, let's go back, and in our main camera, if we hit play, we can see that our scene looks like this, and it's starting to take a bit of form. So let's go out, and we actually can change the position of our camera by moving it up and down and rotating it around. And you can see how this will look in the main game by looking at the little square right here, and it shows you how this is going to look later on. Okay, so one final thing I want to talk about is the directional light. So the directional light, if we click on it and make sure that you're on the inspector, we can actually change the color that is rendered from the directional light, and this is the main light source. And as you can see, the colors of our game objects change based on what the color of our light is. Let's change this back to normal, to whatever it was. And in here we can actually increase the intensity. So as you can see, we can move this a lot up, everything looks white, or we can move it down till it becomes 0, but we'll keep it at 1. And another feature of this is that we can actually play around with the shadows. So as you can see, the shadow strength is currently at 1. We can move it down, and you can see the shadows of our blocks actually getting dimmer and dimmer until they become 0, or they can be very strong. I'll keep it at around 0.8. We'll save that. And now we have our playground and our world set up. In the next video, which is in the next section, section 2, we'll be adding our player, and we'll start tweaking around and learning about character control. So before we do that, I want to issue you a challenge, and your challenge is going to be to set up your own world. So you don't need to create the playground that I've created. You can go ahead and create your own. So create the environment on which we'll build our playground, create materials with your own preferences, and add them to your environment. So pause the video right now, go ahead, play around, see how rotation works, see how scaling works, create your own material, play around with the emission, see what works, see what doesn't, generate a couple of lighting. And before we move on, maybe some of you will have this problem, maybe none of you will have this problem, but in lighting, make sure that the auto generate is off. So when the auto generate is off, you can generate your own lighting, and it's created right here in this folder right here. And let's change this to the playground. Yes, we can reload, and now our scene is called the playground. So as I've said, the challenge is still up. Pause the video and go do the challenge, and I'll see you in the next one. Welcome back, my fellow game developers. As you can see, we've added a player. Actually, it's sort of just a capsule right now, but well, it represents our player. I think he looks cool enough. He looks like a RoboCop, but we've added a player, which is a capsule. We've added eyes to our player. We've added a character controller with a player script, and we've learned a lot of things like character controller, a pivot, and parent and child relationship. So let's not waste any more time, and let's get started. Okay, so let's start first of all by creating a body for our player. Now right click in the hierarchy, go ahead to the 3D object, and let's go ahead and create a capsule. Let's reset its position, and now we have it on the 0, 0, 0, and let's move it up just a little bit. Now if the light gizmo and the camera here are a bit bothering you, just like it's bothering me, let's go ahead and reduce the size of them, or we can actually turn them off completely, but we won't do that. In here, in the gizmos, you can actually click on here and you can make them smaller so they don't look as glaring and they don't distract us from our main tasks. Okay, great. So now we have this capsule right here, and let's go ahead and increase the scale around 1.6. Let's make it 1.6, make it a bit bigger, move it up a bit, and this capsule will actually be our players, or let's simply call it the body. Great, so now we have a body that represents sort of our player. Next thing we're going to do is we're going to add a bit of personality to this capsule right here by creating a eyes, well, the eyes. Right click in the hierarchy, go to the 3D object, and let's go ahead and create a cube. Again, let's reset its position and put it up here. Let's make the eyes, well, actually the eyes should always be smaller, so we'll make like this, and scale it down on this axis also and these axes also, and let's move them to the front. Let's go into the materials and add the plane material to our eyes, and let's call this, let's look at that. Yes, looks much cooler now. Let's move these up a bit. So now we have this RoboCop. Doesn't he look like RoboCop? I think he does. So now let's scale this up a bit on the left and right. Okay, very nice. So now we have the eyes. Let's rename them as the eyes. Okay, great. Now, what's the problem here? Well, the problem is that our body, if we move it, it moves without the eyes. So they are not moving together. How are we going to fix this? Well, we can use something in Unity that is called parent-child relation. So if we move the eyes onto the body, you can see that the eyes become a child of the body. So now when we move the body, the eyes actually move with our body. And let me explain a bit more what all of this means. So what is parent-child relationship? So the child will move, rotate, and scale with the parent game object. It's used for creating a body of objects that move together. So just like your arms are attached to your body when your torso, when your torso moves forward, your arms move with your torso. Now this is a bit of a weird explanation, but you get the point. So child moves, scales, and rotates with the parent. So children can also be parents to other game objects. So we can create children to the eyes that are currently the children of the body. So we can create as much children as we want. And finally, child transform properties are relative to the parent. So what does this mean? So let's go back. So in here you can see that the eyes position is currently 0.612 and 0.46. Well, actually, if we move the body right now, you'd expect that the position of the eyes should change. But if we go back to the eyes, you can see that the position is still 0, 0.6 and 0.4. This means that the child objects, the position and rotation and scale are actually relative to the parent object that we have. Okay, great. So now that that's clear, let's go ahead and create another game object, and this time it's going to be an empty game object, and this is going to be our player. We are going to reset its position. Let's reset the position on the X and the Z of our body right here, and let's put it under the player. So now the player is the parent, the body is a child of the player, and the eyes are the child of the body. So now our player, when the player moves, the body, the eyes move with him. Now, great. Next thing we're going to do is we're going to add a character controller. Now, before we do that, let's explain what character controller is. So what is a character controller? It's used to control a first person or a third person character in your game. Now, of course, we are using the first person. We're going to be creating a first person shooter. So we are going to be using it for our first person. It's more realistic than using rigid bodies. Now, a rigid body. Now, we still didn't learn what rigid body is, but later on we are going to be explaining everything about rigid body, and it actually adds physics to a certain body to move through the world. And using character controller is actually much more realistic than using a rigid body. It allows for more fine tuning. So, for example, we want to jump, move, add velocity. Later on, you'll see that it's much better than using a rigid body. And finally, it doesn't get affected by forces. A rigid body, when added to a game object, makes that game object susceptible to the physics around it. So forces and different things will affect it. We don't want to have that on our player. Despite what you might think, whenever you play a game, it doesn't actually get affected by the forces around it, except for ones that we want to affect the player. So this is the whole point of the character controller. Now let's go back into Unity and let's add a character controller on our player. The way we add a component is we click on the object that we want to add a component to, which is our player. We go to the inspector. We have this add component here. So we click it and we can type in character controller and just add it right here. And as you can see, the character controller is actually under our player, and that's because, let me show you what this means. Because now, if we look back up here, we have the global settings. If we click on the center right here, it becomes pivot. And pivot is actually the center of our current game object, and it's where everything revolves around. This is why the character controller is in the middle of, or actually the player game object is in the center of our character controller, so we'll need to move it up a little bit. So the way we move it up, in here we have the option to move the center. So we'll move this up a bit and we'll increase the height. So let's make the height to fit our capsule, and we can also increase, or actually not too much, we can increase or decrease the radius. Actually, that radius is good enough. And one final thing, go to the body and remove the capsule collider, and go to the eyes and also remove the box collider. So the only thing that we need is the character controller that gives us the ability to interact with the world around us. Okay, great. So now we have this character controller. And as you can see right here, it also has a slope limit. So the slope means the angle at which the character can ride on or move up on. We have the step offset. So what is, for example, let's say we have this step right here. If we decrease it a lot, our player will not be able to step on it. And we also have the height and the radius and the center of our character controller. Now, final thing we want to do is we want to add a script to our player, and it's actually going to be your challenge. So your challenge is going to be to create a player script. So create a folder for the scripts that we are going to be adding, create a C# script and name it player, add it to our player object, and finally open up the script in Visual Studio. So pause the video right now and go ahead and do the challenge. Okay, welcome back. Hope that wasn't too hard of a challenge. We already did this a couple of times, or maybe just one time. So in here, right click, create folder. We'll call this the scripts. Inside of scripts, we are going to right click, create, and create a C# script. Make sure that you call it correctly the first time. So player, yes, hit enter, wait for it to compile. Okay, so now it's ready, and we're simply going to go ahead and attach it to our player. We're going to save that, click on player, and now we have this script attached to it as a component. Double click on player, It will open up in Visual Studio and everything should be working correctly. Now, before we move on, let me just tell you about something. If your Visual Studio is not working, I saw this problem in a lot of people. So go into the Edit, Preferences, External Tools, and in here make sure that the external script editor is the Visual Studio Community. There are different things that you can use. Maybe you have Studio Visual Code or something, it's called like that, and it will not open up correctly. So make sure that you have Visual Studio Community as your external script editor. Okay, great. So now that we're done with this, in the next video we are going to be adding a bit of character movement to our player. So I hope you enjoyed the video and I'll see you in the next one. Oh, before we go, I forgot to do something. Go into the source tree, stage all of our changes, commit them, and we'll call it here, Edit My Player with a Character Controller. Commit that, and now we have it in our branches. I'll see you in the next video. Welcome back, my fellow game developers. As you can see, our player script right here has a bit of difference from before. If we look in our Visual Studio, you can see that we've created two variables. In this video, we'll learn what variables are, how we can create them, and you are going to create one for yourself. We'll also learn how our character controller can move, and on top of that, we'll also understand what Vector3 is and how to play around with all of that. So let's not waste any more time and let's get started. Okay, so let's get started. But before we start, I want to do something. As you can see, our hierarchy right now is completely filled with random stuff. So cube 1, cube 2, the plane and the player and the directional light. We don't want that. We want to put things in their respective place and have a, well, nice looking hierarchy that we can look at and understand what the things that we have in our environment or in our current scene are. So let's go ahead and creating empty game object. And this is going to be, let's reset its position, and this is going to be called the environment. So environment, I'm not sure if that's how it's written. And let's take the plane and all the cubes, and the way we can choose all of these is click on the plane, hold down shift and choose the cube. Now you select all of these and put them in the environment as children. So now we have the environment, which has all the cubes and the plane, and we have the player, the main camera, and direction, and it looks much nicer. Great. Now, next thing we're going to do is we're going to set up our player movement so we can later on move him or her. Depends on how you want to make your player be. And we are going to set up the environment or the code for him to move in. So let's open up our script and look how are we going to do this. Well, first thing we want to do is we want to create a variable. So what is a variable? Let's talk about that. Variables are like boxes. So for example, let's say we have a variable that is a box or a box that is called lives, and we put inside it a value of 3. So this becomes a variable with a name lives, and it has inside of it a value of 3. The way we write it in code is public. So public, it can be either public or it can be private, and this is the accessibility. So when we say public, it means that everyone inside of this current class can use this variable. If it's private, only this class can use it and nobody outside of it can access this variable. We create the type meaning integer. We have many types that we'll cover in just a bit, but we have the integer right now, and 3 is an integer, so we give it a type after we give it an accessibility. Next thing we do is we give it a name, and usually names start with a lowercase letter at the beginning, and then all subsequent words will have a capitalized first letter. And finally, we give it the data or the value of the variable. So let's talk about the different types of variables that we have. And this does not include everything, but currently, for now, we'll just cover the main ones. So first thing first, we have a float. Float meaning that we have, for example, 4.8, 4.7, 6.9, anything you want. And whenever we create a variable that is a float, we add f to the end of it in the data. So this can be used for velocity, for height, for speed, for anything that can be variable, and it's not simply 1, 2, 3, 4. It can be 4.6, 4.9, and etc. Next thing, we have a boolean, and a boolean is very important in coding because it allows us to choose whether something is true or it's false. And we are going to be encountering a lot of boolean throughout this course, and you'll see how important it is. So a boolean, for example, in here, a player or your enemy can either be in two states, whether he is dead, which means is dead is true, or he can be alive, which means is dead is false. So a boolean is a variable that can take either a true or it can take a false. And finally, we have the string variable, and a string variable means it's a string of characters one after the other. So my name, as you can see right here, and in the is that, the first word of the variable is in the lowercase, and the second word, the first letter, is in the uppercase, just like is that, just like my name. And this is the convention of how we name our variables. So a string variable is a string of characters which you can put in like Michael or a car or door or anything that you want to name. Any word is basically a string. So let's go ahead and create our first variable. Back in Visual Studio, we go right here into our script, and we are going to create a public. Public meaning that we can use this variable anywhere we wish. We're going to make it a float, and we're going to call this the speed, and we're going to give it a 12.5f. Great. Well, actually, I think this is too much for later on, but we can tweak it later on. So when we make a variable public, if we go back into Unity, wait for it to compile, anytime now. So when we click on player, in here you can see that we already have this variable speed, and it's showing up right here because we made it public. If we go back in the Visual Studio and we make this a private variable, we need to save it, of course, back in our inspector, and the speed is no longer available for us to play around with. So make this back to public, save that, and now we have the ability to tweak around and play with our speed. Now, next thing we're going to do is we want to actually start moving our player. And the way we move our player is through the character controller, and you can actually create a variable that is of type character controller. This is actually part of your challenge. So we've learned what variables are, we've learned how to create variables, and now it's time for you to create a character controller variable. So create a new variable of type character controller. Don't worry, Visual Studio will help you out. Make it a public variable and name it my character controller. Make sure it appears in the inspector. And as a bonus challenge, even though we haven't covered this yet, you can add the character controller on the player to the variable in the inspector. So if you're a bit scared, don't be. This is extremely easy. Pause the video right now and go try to do your best. Okay, welcome back. So I hope you didn't just stare at the screen and were petrified of the challenge that I just gave you. Okay, so first of all, we said that we want to create a public variable. So we're going to make this a public variable. Second thing we said, we're going to make this of type character controller. So we're going to write even char, and you can see that it already gives us a suggestion, which is character controller. Hold down tab. So now we have a variable of type character controller that is public, and we are going to name it my. Make sure that the first word has a lowercase first letter, and then controller. The second word has a big C, an uppercase. Put in the semicolon, save that, and now if we go back in Unity and we look at our inspector, we should see that my character controller shows up right here, and this is the bonus section. You can see that it has none, and it requires a character controller that we thankfully have it right here. So you simply click on this character controller and drag it into its place, and we save that. Great. So now we have a reference to our character controller that we can actually start moving. Now let's try this out. Before we do, let me explain to you what a vector 3 is. Now I don't have any slides, but I don't think we'll need it. Vector 3 are just like the vectors that you learned in school. We have this x vector or the z vector, the blue z vector, which is called the forward vector. We have this x vector, which is the right vector, so vector 3 right, and we have this y, which is the vector 3 up vector. Very good. So now that we know how vector 3s work, we are actually going to use them to move our character just a little bit. And for now, so we are in the challenge back in Visual Studio. So now inside of here, we are going to move our character. So the way we move our character, we're going to get our character controller, and we're going to use a method that is called move. And if we read on it, we can see that a more complex move function taking absolute movement deltas. You don't need to understand all these complex words in here. All you need to know is that this moves our character, simply as that. And if you look right here, you can see that it actually takes a vector 3 inside of this. Well, it requires a vector 3 in order to move. So let's save that, or let's use that. And in here, we are going to create a vector 3 dot. And we can actually choose if we want it to be up, to be right, or to be forward. And we can simply add a semicolon. Let's save that, and let's see what happens if we click on play. So now let me look in my game. So this is how it looks. You can actually play around with the camera, so you can move it up and rotate it down, rotate it like that, so we can see our player moving. Save that, hit play, and holy damn, where did that player go? That was extremely fast. Okay, so the cool thing about variables is that we can actually now adjust the speed at which our player moves. So back in here, we can actually multiply this by our speed, and because you saw how fast that was, we actually need to reduce the speed. So now we can make this, instead of 12, let's make this 0.1. Save that, let's try this again, and this should make our player move slower. So hit play, and as you can see, he moves slower. And if we make this negative, he should come back and let me just move him a little bit forward so we can see. Okay, come back. And as you can see, because I'm manipulating the velocity of our player. When it's negative, he's moving backwards, and when it's positive, he is moving forward. So now we put him to 0, so he completely stops dead in his tracks. We make it 1 and he flies away. So I hope you enjoyed this video. Let us commit our changes. And I'm not going to be committing my changes every single video, or at least I'm not going to be showing you that I'm committing. You need to create this habit. Whenever you get to a certain point, a significant point in your project, always go back and commit your changes. So what did we do here? Well, we set up my player or my character controller movement without an exclamation mark. So let's commit that. Now we have a new repository, and in the next video we are actually going to start controlling our player with our WASD keys and taking our first steps. So I hope you enjoyed this video, and I'll see you in the next one. Welcome back, my fellow game developers. In this video we are actually going to be learning about input system in Unity. So now when we hit play, instead of just moving our player, we can actually use the WASD keys in order to move him forward, backwards, to the left, and to the right. Now his movement is still weird, and as you can see, he has no gravity on him, but we are going to start with the basics of Unity's input system. So let's not waste any more time and let's get started. Okay, so first thing I want to talk about is how are we actually going to be moving our player. So if we click here on player, we've already talked about the different kind of axes that we have. And we are going to be moving our player first of all on the Z-axis, which means we are going to be moving him forward, and we are going to be moving him on the X-axis also. So this way our player will be moving in these two directions. Now, what do we actually need in order to start moving our player? Well, of course, we are going to be needing some inputs from the person playing our game to move our player. And how are we going to do this? Well, I thought about simply going through and telling you about all of this, but I thought about it more, and I wanted to actually show you the thinking process behind actually figuring out or finding yourself in some kind of situation where you want to add a new mechanic and how you can actually do it. So what is our goal? Our goal is to create movement, or first of all we get input from the person playing our game, then we want to create movement along these two axes. So how do we start our thinking process? Well, as all great things start in our life, we go to Google. We type in input Unity because we want to get some kind of input from Unity, and we see here that we have the documentations for the Unity 3D, which is the perfect place to get any kind of documentations. So we click on this one, we open up the link, and we get the input documentations for Unity. So we can read in here, it's the interface into the input system. Very nice. So this is what we need. So we read, we see what's here. We can see that to read an axis, we use the input.getAxis. Perfect. This is exactly what we need. And we can see here that we have one of the following default axes, which are horizontal and vertical, and are mapped to the joystick AWSD. How perfect is that? Well, in the real world, when you're doing this alone, of course, this process will take a bit more time, but I'm just showing you how the thinking process behind figuring out these mechanics actually work. So great, we need the get axis. So we click on the get axis and we open up the second documentation and we look here. We can see the way we can access these get axes, and we see that it requires a axis name that we've just saw, which is horizontal or vertical. We can read the description, which tells us that it returns the value of the virtual axis, and the value ranges from -1 to 1. Great. Not only that, we also get the option to look for some kind of example, and here we can see that translation, how this all works, and how we can use it or implement it inside of our code. We even get the hint that we need to use it inside of update, because we want to be getting input from our player every single frame. So great, this is exactly what we need. We can also see in here that to set up your input, you should go to Edit, Project Settings, Input. How nice is that? So now with all that information, let's get started with adding inputs to our game. So we'll open up the script in here. Let's remove this for now. And let's start getting a bit of input from our player. So first of all, we need to get the axis on the horizontal plane. So we'll create a variable in here. It's going to be a float, and we're simply going to call it the x, because we are moving on the x axis. So we'll create an input, and we'll use the get axis, and in here we are going to write horizontal. And a small warning here: whenever you are using string inputs, which by string I mean inside these two quotations, you need to make sure that you write it correctly 100%. Because if, for example, we write horizontal using the lowercase h, this will not work. We need to make sure that it is the capitalized H. And not only that, if we have the option, we can also go and copy this string reference. Well, where do we copy this string reference? Well, we've just saw that we can actually go into Edit, Project Settings, and look at the input. So let's go ahead and do that. We open up Unity, we go into the Edit, Project Settings, and where is our input? Well, there is our input. We click on the axes, and in here we can see all the different type of axes that we can access in our inputs. So let's click on horizontal, and in here we can see that in order to move horizontally, we need to use the A key and the D key, and we can go ahead and copy this, go back in our Visual Studio and paste it right here and close it off with a semicolon. Very nice. Now, next thing we want to do is we want to get the movement on the z-axis. So let's go ahead and create a float, z-axis, input dot get axis, and in here we are going to be using the vertical. So back in our Unity Project Settings inputs, let's close the horizontal, open up the vertical, and in here we can see that it's the S and W for the negative and the positive. We can also use the up and down arrows. So copy vertical, Control C, go back here, Control V, close it off, save that, and now we have inputs in our game. Very nice. Now, what should we be doing next? Well, next thing we want to do is we actually want to combine both of these movements together and add them to the character controller movement. How are we going to do that? Well, first of all, because we are working in vector3, we are going to create a variable which is of type vector3, and we're going to simply call it the movement, and this movement is going to be the x-axis that we've just created in here, the input of our player, times the transform dot right. Now you've already saw what vector3.right is. Now we are working on the transform.right. And what does this transform.right mean? You already know what right means. Let's dock this in here, back in our scene. So right is this axis right here. It's the x-axis where we move to the right. But what does transform mean? mean? Transform is actually the transform of the player. And whenever we, for example, in here, when we write transform, just like that, we mean the transform of the game object which has this player script attached to it. So, because this player script is on the player game object, that means that the transform that we access from our script is the transform of the player. And when we write transform.write, we mean the right axis or the x-axis, which is on this exact game object, which is our player. So now that we know what this means, we can go ahead and add to this transform.write the z, which is the input on the vertical axis, times the transform. And I'll leave you to figure this out on your own. Take a couple of seconds just to know which one are we going to use, the up, the forward, or the right. Okay, time's up. I hope you tried your best. Anyways, we are going to be using the forward, and we are going to add the semicolon, and we are going to save that. So let's just talk a little bit about what's happening, because all of this is very new. First thing we did is we got the input on the x-axis for the horizontal. We then got the input on the z-axis, which is called vertical. We then combined both of these by multiplying the horizontal input by the transform.write, which will allow us to move on the x-axis like this. And then we multiplied the z input or the vertical by the transform.forward, which will allow us to move in the forward direction. Very nice. So with that established, next thing we need to do is we need to actually add this movement to our character controller. And this is actually part of your challenge. So your challenge is going to be to, first of all, look up character controller documentations in Unity, just like we did right now, using Google or whatever method you want. You then find the character controller.move in the documentations. We've already used it, but I want you to go ahead and try to do this on your own and really get a feel of how all of this works. And finally, I want you to add the movement to your character controller in the game. So we've already done this, but I just want you to actually get a sense of how all of this works and how you, on your own, when you go out to the wild west of game development, can actually go through these steps and find out the documentation and use the movement. Anyways, pause the video right now and go do the challenge. Now, we've already talked about how we add movement in the previous video, but let's just delve a little bit deeper into how this actually works. So, just like we looked up the input Unity, you can actually also look up the character controller in Unity, and this is the documentation for it. So you can go ahead and read all about it, but what we are interested in is the move right here. And if we read next to it, you can see that it supplies the movement of a game object with an attached character controller component. Great. So this is what we need. Click on the move. We open up a new script in here, and as you can see, this is the move. It takes in a vector 3 and it supplies the motion to the game object. We can also see how, or we can see an example in here of how this character controller actually moves. And you can see that we are pretty close to what the example is showing us. In here, the movement is the input axis on the horizontal and the input axis on the vertical. And it's pretty similar, but we are doing it in a bit of different way. So let's go ahead and add the movement to our character controller. We already have the reference, which is the my controller. So my controller dot move, and in here we are going to add the movement that we just created. Very nice. Make sure to save all of that, And let's go ahead and test this out and see if it works. So save that, hit play. And now when we press the W, our little capsule here should move forward. Okay, and it's super fast, but at least it's working. And if we move to use the WAD key, the A or D key, we can also move him to the right, to the left, forward, and we can actually also move him horizontally. But as you can see, we have no control over our player at all. So in the next video, we are going to be controlling our player's movement using our speed, and we are also going to be learning how we can detach the movement from our frame rate, and we'll also be learning about methods and so on. So I'll see you in the next one. Welcome back, my fellow game developers. In this video, we are actually going to, first of all, start to control our movement with the speed variable that we've created before. And we're actually also going to be learning about how to make this all frame rate independent, which adds more dynamic movement to our game. Finally, we'll learn about public methods and private methods, and we are actually going to create our own. So now when we hit play, we can see that we can move our player at a certain speed, but if we increase this to, let's say, 50, we can move a bit faster. Where did he go? Okay. And if we put this to, let's say, 2, now we can barely move at all. So let's not waste any more time and let's get started. Now that we have movement, or we can use input in order to move our player, it's time to control our player, and that is part of your challenge. So your challenge, let me get my laser, is to control movement speed. So you'll need to multiply the speed variable we created by the movement, and then you'll need to adjust the velocity from the inspector until it feels good enough for you. So it's your job to determine how fast you want your player to be moving through the world. We've already done this, so pause the video right now and go do the challenge. Okay, welcome back. So how are we going to do this? Let's open up the scripts, and in here, before we make the movement, or before we add the movement to the controller, we are actually going to take this movement and we are going to say that this movement is equal to the movement that is already present times our speed. So now, whenever we take the movement from here, we multiply it by the speed, and then we put it back into the movement right here, and this movement gets added to our movement, or to our controller.move. So now, when we hit play, we move our character and he is much slower. So we can adjust this to, let's say, 0.7, and now he moves a bit faster and he's gone somewhere. Let's try this again. And let's say we want to make this 1, or maybe not 1, maybe let's say 13, and he should be flying off into the distance as soon as we press the W key. Yep, that works pretty well. But there is still a slight problem. If we go back in here, we can see that update is called once per frame. That means that every single time we press the W or A or S, it's being called multiple times, and the speed is extremely high. And you know about frames per second whenever you are playing a multiplayer game, so it's the FPS. And the problem here is that we are using very limited resources. So let's say in game in here, we can click on the stats and let's hit play. And you can see that the frames per second in here are 700 to maybe 900. It will depend on your hardware. So now every single frame, this speed or movement is added to our player. And this is not good because, for example, if we start lagging in our game, our movement is going to deteriorate as the game progresses. Or if the frames per second are very high, our movement will be much faster, and this is not what we want from our game. We want to have a steady movement no matter what the frames per second are. So what we want to do is we want to detach the velocity of our player from the number of frames, and the way we do that is by actually multiplying this movement by the time dot delta time. And what does this time dot delta time means? If we hover over the time dot delta time, you can see that the completion time in seconds since the last frame. So this gives us the time between each frame, which means that this becomes independent of the frame rate. And you'll see now that our movement will become much slower because it does not depend on the number of frames that we are moving in. So we take our movement from the inputs, we multiply it by the speed in order to control it, and then we detach it from the frame rate. So we do that by multiplying it by time dot delta time. So we save all of that. Now back in Unity, if you have a very low speed, you'll notice that we are going to be extremely slow right now. So when we move, we barely move. So we'll need to increase this to 1, maybe even 1 will not be helping. Yes, you can see that we are barely moving. So we'll need to adjust this and make it 12.5, just like we did in the beginning. So now we have a much better movement for our player, and it's much more reasonable, it's much better. Let's increase it maybe to 20. So now we can move our player and he can even step over and climb. But unfortunately, he does not go down because he still doesn't have any gravity. Okay, great. So let's go back. Let's explain this one more time. We get the inputs on the horizontal and the vertical. We multiply it by our transforms. So transform.right for the x, transform.forward for the z, or the horizontal and vertical respectively. We multiply this movement by the speed in order to control it. We then multiply the movement and the speed by time.delta time to make it independent from the number of frames that we have, and then we add the movement to our character controller. And as a final step, we want to put this code in a separate method. So whenever we are working inside of Update, we always want to keep things clean and very simple. So for now in Update, we have all this cluster of code, and we don't want to have all of this inside of Update because we are going to be adding shooting, crouching, and so on to our player. So we're going to extract this into its own method. And before we do that, let me just explain to you what methods are. So method structure. This is the method structure. So just like we have the accessibility type for a variable, we also have an accessibility type for the methods. So whenever you create a method, you need to make sure to know whether it's private, which means that it's only used inside of this class, or if it's public, which means it can be used outside of the class. Next, we have the return type. Now, as you saw, every variable has a type, but methods don't need to necessarily have a type. And whenever the methods don't have a type or don't return anything, they are called void. For example, the update doesn't return anything, so it's a void, and start doesn't return anything, so it's also a void. We'll learn about returning later on, but for now, just know that a method can have no type at all. Next thing, we have the name of a variable or of a method, and we named variables by first word being a lowercase, but whenever we are naming a method, every single word is in the uppercase. That way we can distinguish between variables and methods. Finally, we have the parameter, and in this parameter we can actually send information that this method can use. For now, we will not be sending any parameters. If it's empty, that means it doesn't use anything. But later on, you'll see that some methods will require parameters to be sent to it to use it. We'll get to that later. So let's go ahead and extract these couple of lines. The way we create a method, we can go down here and create a void and make this the player movement. And then we take all of this code, we cut it. The way we cut this is we click on Ctrl X, we click on Ctrl V to paste all of this in here, and we call this method the player movement in here. We save that. So now in update, whenever we start update, it looks and it sees that it needs to call the player movement. It looks through the code and sees that we have player movement, and we start with all of this code. So let's save that, back in Unity, hit play. Let's make sure that all of this still works. So now, yep, we can still move our player. He still moves and he still floats in the air. So, and in here, in the masters, we can see that we have a couple of uncommitted changes. We stage all of that, commit all of that, and what should we call this? Moving player using inputs. We commit all of that. Great. So now we have movement set up, and the natural course of action later on that we're going to do is we're actually going to set up the first-person camera on top of our player so it moves with us as we move through our world. So I hope you enjoyed the video, and I'll see you in the next one. Okay, so first thing we are going to do is we're actually going to take our main camera and we're going to reset its position so it's on the player. We are going to move it into the child of the player, so we'll move it up here, and let's go ahead and position it right in front of it, and we can actually see what the player and the camera can see, or the main camera can see. So let's position the camera somewhere around here maybe. So make sure that we do not see these two black dots. We'll fix that later on, but for now just move it. Oops, it's not even in place. So let's move it to the center and up a bit so it's just over the eyes. Okay, great. So with that done, we'll simply save it, and because the main camera is now childed to the player, it will be moving with the player. So when we hit play, now when we move our player left and right, you can see that we already have a first-person view of our game. How cool is that? Okay, but now we want to move to the next level, and the next level is we want to actually start moving this camera around using our mouse. Let me first of all explain how this movement is going to work. So first of all, we want to be looking left and right. And in order to do that, we are actually going to take this player and we are going to be rotating him around. So when we rotate the camera using the mouse button, we are going to rotate the entire body of the player. But when we want to rotate up, we don't want to be rotating our player the whole way up. We don't want this movement to be happening. We actually want to only be rotating this camera when we want to look. When we want to look up and down, we only want to be rotating this camera. So let's go ahead and start doing that. We are going to, of course, be taking the input from the mouse, and then we are going to be applying it to the different transforms that we have. We are going to actually be using something called the get axis raw and not just the get axis. Now let me show you the difference between these two. So this is the normal input.getAxis, and we can see that the value is in the range of -1 and 1. So it moves from -1 to -0.9 to 0 or to -0.8 and so on. But using the getAxis raw, it actually, if we look in here, the keyboard input is always either -1, 0 or 1. So it takes definite positions on the spectrum, or it's not a spectrum, it either takes a -1, a 0 or a +1. And why are we using it this way? If you continue reading, you can see that this is useful if you want to do all the smoothing on the keyboard or the mouse input. So we want to be able to control how much we rotate. When we look left and right or up and down, we don't want to build up to that position. We want, as soon as we look to the left, we want the camera to move that way or start moving that way. We don't want it to slowly build up from nothing to moving that way. We want to have it instantaneously. So let's go ahead and do that. In update, under the player movement, we are going to create a float, and we are going to call this the mouse X. And in order to take the input, we are going to use input getAxis raw. And in here, what should we be using? Well, let's go into our project settings in here, and let's see, we want to be using the mouse X. So we'll copy all of this because it's a string reference, and whenever we have a string reference, it's usually better to copy it. Let's save that. Next thing we want to do is we want to actually be applying this rotation to our body transform. So in here, we are going to write transform, which is our current transform, and we are going to be rotating it. So we'll be rotating it. And if we, let me just delete this. And if we look at the rotate, we can see that it actually takes a vector 3. So we're going to be adding a vector 3. And which vector are we actually going to use? Well, it's going to be the vector around which this camera is going to be rotating. So back in Unity, in our scene, if we look around which axis is our camera actually rotating when we are looking left and right, or our player is rotating around. So if we look in the transform right here, we can see that when we hold the Y and start rotating, the player starts rotating around. So we are rotating around the vector up. So let's see that again. So we rotate around the Y right here. You can see it on the transform. So let's go ahead and apply it. So it's the vector 3 dot up, and we're going to be multiplying it by the input that we got on the mouse X. Let's save that. Let's go back into Unity and let's hit play. So now we can see that when we move our mouse left to right, we can actually look around. So now, even when we move forward, when we look in another direction, we move in that direction because we are moving the entire body or the entire transform of our player. But there are still a couple of things that we need to fix, and one of them is actually controlling how fast we rotate. So we want to add a mouse sensitivity variable. So up here, we are going to create a public because we want to be changing it from our inspector. So this is a public float, and we are going to call this mouse sensitivity, and let's just set it at 100F for now. And down here in the input axis raw, we are going to be multiplying it by the mouse sensitivity, and as long as we're here, we are also going to be multiplying it by time.delta time, so it's frame rate independent. Now back in our game, let's save that. Did we save everything in here? Yes. Hit play, and now we can look around. It's a bit slow, as you can see, so let's go ahead and increase it to 200. Is that better? Let's see. And nope, it's not that good. Let's make it 500. And now we can actually rotate and look around much better. Maybe we can increase it later on. We'll see that. Let's actually make it 700. See how that works. Yep, I'm satisfied with 700. Looks good enough. Anyways, now that we have the rotation around the y-axis, or looking left and right, it's time to make the rotation up and down. And actually, I don't feel like doing this, so I'm going to issue you a challenge for you to do it. And your challenge is going to be to, first of all, get the raw axis value for the mouse Y. Excuse me for the typo right here. So get the raw axis value for the mouse Y. Then you need to make sure you control it with the mouse sensitivity. And finally, you need to make it frame rate independent. Now, you don't need to apply all of that to the rotation of the camera. We'll do it later on. All I want you to do is get the input, use the sensitivity to control it, and make it frame rate independent. So, pause the video right now and go do the challenge. Okay, welcome back. So, first thing we're going to do is we're going to create the mouse Y, and we're going to get the input dot get raw axis. So where is the get raw axis? And it's going to be the mouse Y, but because it's a string reference, we are going to actually go ahead and get it from the input manager. Mouse Y, we'll copy that and paste it right here. We're going to add the mouse sensitivity to control it, and we are going to make it frame rate independent by multiplying by time.delta time. Now, we want to be applying this rotation to the actual camera. So we need to get a reference to that camera. Up here, we are going to create a public. And what type should this be? Well, because we are using the rotation, that means we want access to the transform of the camera. So we are going to make this variable of type transform, and we'll just call it my camera head. And we'll save that. So now we can actually go into Unity, go to player, and in here we'll have the option to add my camera head. Let's save that. Now back in Unity, we want to be able to control this camera vertical rotation. So we are going to also be creating another variable, which is private float camera vertical rotation, and we are going to be adding to this camera vertical rotation minus equals mouse Y. Now, why are we doing this? First of all, let me explain what this minus equals means. This means that we are taking this camera vertical rotation and then removing the mouse Y from it. So in order to make it look more professional, we simply remove this and we add a minus back here. So this is the same. Now, why are we making it a minus equals? Well, because if we look in our camera in here and we want to rotate it around the x-axis so it moves up and down, you can see that when we look up, the value actually becomes negative. And when we look down, the value is positive. So for some reason, well, actually it's because of the way Unity is set up, when we look down, it's positive, and when we look up, it's negative. So we want to be actually inversing it, because when we look up with our mouse, okay, the value goes to +1. That means that we need to reverse it in order to make it minus. So this value, the mouse Y, will be a positive value, and the camera vertical rotation will be a negative value. So we will be able to actually look up when we move our mouse up. Let's get our camera head, and we are going to be applying not just rotation this time, we are going to be applying local rotation. And why are we doing this? Well, because now we are not rotating our camera, we are rotating it relative to the transform parent. So if we hover over the local rotation, you can see that local rotation is the rotation of the transform relative to the transform's rotation of the parent. So we want to only be rotating the camera. And if you look closely, you can see that the type is of type quaternion. And what is quaternions? Well, quaternions are a way for Unity to understand rotations from vector 3s. Now, you don't need to go all in. I'm not even sure what quaternions are. They are very complicated mathematical formulas. Don't worry about it. Simply know that whenever you want to do rotations, you need to use quaternion. So we'll take the quaternion, and we are going to use Euler, and this, I'm not sure if it's pronounced Euler. Anyways, Euler returns a rotation that, well, it uses a vector 3 and converts it into rotations, and now we can have a rotation. So Euler, and in here we are going to be rotating only around the x-axis. So it's going to be, first of all, the camera vertical rotation. The y-axis is going to stay at 0, and the z-axis will also stay at 0. So we're going to save all of that, and let's go ahead and try it out in Unity and see what happens. So in player, we have the reference camera, we have the sensitivity at 700. When we hit play, we can actually start to look up and look down, and we can move left with our camera and move right with our camera, and we can start walking, and we actually have a first person looking camera. How cool is that? Now, before we go, I just wanted to show you something that we didn't cover before. If we change the sensitivity in here, maybe some of you have noticed, let's say we put it up to 1000. Okay, so now we look faster up and down and left and right, but when we exit play mode, you can see that it goes back to 700. And this is a very important feature of Unity. This is because sometimes we might adjust things in play mode and they might break our game. So Unity makes sure that it resets everything when we get out of play mode. So whenever you adjust something, make sure that you remember what you adjusted and then apply it when you go out from game mode. So in the next video, first of all, we don't want to be looking very much up and down. So we can look all the way around ourselves, which is of course a very bad idea. We need to find a way to keep it at certain angles, and we also want to remove the little jittering that we have. So this will all be done in the next video, and I'll see you then. Welcome back, my fellow game developers. In this video, we are going to make our cursor disappear. So now it's not in our way. No, actually, we are going to do much more than that. First of all, you can see that we can no longer see our backs when we move up and down, and we actually just removed our main camera from the player and we added a head, and now our main camera follows our head as we move through our world. This makes our camera much smoother and much better looking. So let's not waste any more time and let's get started. Okay, so first thing we want to do is we actually want to stop our camera from rotating behind our back up and down, and for that we are going to be using something called a mathf.clamp. So let me explain what that is. So what is mathf.clamp? First of all, it keeps the value between a certain minimum and a certain maximum. So it fixes a value from over or under shooting. So we can determine which value we want to change. We then determine the minimum and the maximum, and that way this value will not over or undershoot while over and under the maximum and minimum. This is the way we write it. So first of all, we have clamp. We give it the value which we want to be changing. We give it the minimum and the maximum. We then have it return a float of the value clamped between the minimum and maximum. So let's go ahead and do that. First thing first, we have our camera vertical rotation. So we are going to get this camera vertical rotation before applying it to our camera head. And we are going to use mathf.clamp. And the reason why we're using mathf.clamp is because clamp is a formula of the mathf library, which gives us the ability to access various formulas like clamp and square root, and maybe we'll see later on what else. So what is the value? It's the camera vertical rotation. What is the minimum? We're going to set it to minus 90f, and the maximum is going to be 90f. So let's save that. And now if we go back to Unity, when we move up and down, we should see that we cannot move higher than a certain value. Let me show you in main camera. So currently we are at 8, and if we go down, we can see that we can maximum go to 90, and looking up we can also only go to minus 90. Great, so now we have clamped our vision. But as you can see, when we move, we have some kind of weird jittering in our camera. I'm not sure if you can notice it, but there is a bit of jittering. And the reason for that jittering is because the camera is trying to keep up with our player as he's moving. And that's not what we want. We want to actually have the camera move after the player finishes moving. And for that, we are going to, instead of actually childing the camera to the player, we are going to create an object that is a child of the player that's called head, and then we are going to make our camera follow that object around, and, well, actually not follow, move to the position and rotate with that object. So first thing first, we are going to create an empty game object and under our camera, and we are going to call this game object our head. And why are we doing this? It's because we want to have our head in the exact position that our main camera has. So we are going to remove the head from the child of the camera, put it just as a child of our player, and then we are going to move our camera out of the child. So now, instead of the player having the main camera as the my camera head, it's going to have the head as the, well, my camera head. Next thing we want to do is we want to actually create a script that will allow the main camera to follow this game object. So in the scripts folder in assets, let's right click and go ahead and create a C# script, and we are going to call this the camera move. So now we have a script called camera move. Let's wait for it to compile. There we go. So we'll move the camera move to the main camera, and we'll have it in here. And let's go ahead and open it up in Unity. Now, what are we going to do here? First of all, because we are going to be following or moving to the camera head, we actually need a reference to it. So we're going to create a public transform my player head. Great, so now we have a reference to the thing that we are going to move to. Next thing we're going to do is we're going to move there, and we're going to move there every single frame. And you would say that let's go ahead and use update, but in this case update is not good enough. Why? Well, because there will be some sort of a battle between who goes first. Is it the player that goes first, or is it the camera that goes first, or should the camera go after or before or during? So there will be a conflict. So what we are going to do is we're going to remove update, and we're going to use something called the late update. So late update is just like update. It's called every frame, but the difference is that the late update is called, well, later. Late update. It's called after all the other updates have been called. So what happens here is that when our player finishes his movement, the camera will move to the position of the head on the player, and this will remove all the jittering. So what should we be doing inside of late update? We'll want to move to the position of our player head, and we'll want to rotate with our player head, and that's actually part of your challenge. So your challenge is going to be to move and rotate camera with head. So first of all, in late update, move the camera position to the player head position, then rotate the camera rotation with the player head rotation. And I'm going to give you a small hint. So you'll need to use transform.position and transform.rotation in order to do that. So pause the video right now, take your time, don't be afraid, do your best, and I'll see you in just a bit. Okay, welcome back. So what should we be doing here? We are going to access the transform.position, and because the camera move script is on the camera, that means when we write transform, we are referencing the camera. So camera.position is equal to my player head dot position, and the transform.rotation is equal to my player head dot rotation. Let's save that. And now back in Unity. So now we can actually move our camera anywhere we want. So we can put it up here, save that, and when we hit play, we can see that the camera moves to the position of our head, and it actually moves now with us. So now we move around and the jittering is much less evident, and we can still look up, we can still look down, we can look around, and we can move around. Okay, very nice. Now, what else should we be doing? Well, you can see that we have this mouse right here, and it's very annoying to have it move around. We want to actually be locking it whenever we enter the game mode. So let's go ahead and do that. Back in our script right here, let's go ahead and get the cursor, and we are going to access the lock state of this cursor, and we're actually going to access the cursor's lock mode, and we are going to make it locked. Let's save that, and that's all that we need. We get the cursor, we access its lock state, we go to the cursor lock mode, and we make it locked. So back in our game, when we hit play, we should see our cursor disappear when we hit the screen. So now we can freely move around without our cursor bothering us at all. Great. So we have first person moving, we have, first person movement, we have first person camera movement. The only thing that we need to add in order to finish this is adding a bit of shooting, and that's what we're going to do in the next section. So I'll see you there. Oh, and before we go, we of course need to stage all of our files. So stage all. Let's go ahead and call this commit applying first person camera to my player, and let's hit commit. We now have everything in our project. Look at it, it's starting to come to life. I'll see you in the next video. Welcome back, my fellow game developers, to a brand new video. And as you can see, we've added a big red bullet with a huge collider on it. And not only does this bullet hang in the air, we actually are able to fire this bullet. Well, not ourselves, but it gets fired on its own. And we can also increase the speed to 24. So we hit play and our bullet, whoops, we didn't see that. Let's try this again. So hit play and our bullet flies away just like real bullets, straight forward. So let's not waste any more time and let's get started. Okay, so we know that every gun needs a bullet, and every bullet also needs a gun. So the first thing we're going to do is we're going to create that gun. Now, at first, our gun will simply be a cube that we are going to add as a child of the head. Now, why is it a child of the head? Well, because we want our gun to move left and right and up and down with our head as we look around. So right click on hand, create a 3D object and make it a cube. So now our cube is huge. Let's put the game window right next to our view right here, and actually let's go ahead and child the camera to the head and reset its position, and I'll tell you why we're doing this. So now we can have the camera from the head's perspective, and now remove the camera from the head position, or from the child of the head. So now if we move the cube, oops, nope, that's not what I meant. If we move the cube, we can see how it looks in our game directly next to us. So let's go ahead and scale this down a bit and scale this down like this. Let's move it down, move it a bit to the left, and let's go ahead and create a material for it. So let's duplicate the plane material, and we'll call this let's just call it the gun mat. So gun material. And let's drag it over to the gun and let's make it a blue color. So we'll move this right here, make it blue, all the way blue, and we'll also make the emission blue. So now we have this, or you can make it whatever you want. We have this weird, well, it doesn't need to look pretty in the scene, it just needs to look good in the game, but we're not done adjusting it. First, let's change the cube to a gun, and let's go ahead and make it a bit slimmer up and down, and let's move it a bit to the left and just adjust it until it looks as if it's coming, sort of looking like it's a gun in our game mode. So I think this is good enough. Maybe if we move it a bit like this, and let's see how that looks. And okay, so let's move this game back. When we hit play, we should see our gun moving with us as we move through our game. So now what we need is we need some kind of bullets to shoot with. So just imagine that this is a really cool gun that we use to destroy giant monsters. That will be doing that later on. But for now, use your imagination. Next thing we're going to do is we're going to create a bullet, and to represent our bullet, we are going to create a sphere. So in hierarchy, right click 3D object, and let's create a sphere. This is our sphere. It's a bit big for a bullet, so we're going to scale it down. So let's call this our bullet, and let's go ahead and scale it down. So we press the R key and we move it down, 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 down until it's about this small, so we can still see it, and it's small enough to represent a bullet. So let's maybe make it just a little bit smaller. That looks good enough, and we'll also make it a red color. So we'll duplicate the gun material. Let's go ahead and make it red. And this red color, oops, did I call it red? No, I meant this is the bullet material. So bullet, and it's going to be red. It's not called red, so red. And the emission is also very, very red. Let's add it to our bullet. So now we have a very clear red bullet that we'll be able to see as it moves through the air. Now, we want to move it through the air. That means that we want to add behavior to our bullet. That means that we need to create a script for it. So inside of scripts, right click, go to create a C# script, and we're going to call this the bullet controller. So let's wait for it to compile. No, thank you. Why did that happen? So bullet controller has compiled, and let's go ahead and add it to bullet. So now in here we have the bullet controller, and before we go, let's go ahead and make this sphere collider a little bit bigger. And later on we'll be, of course, going deeper into sphere colliders and other types of colliders, but for now just know that it helps us interact with various objects. So just make it a little bit bigger, and don't worry, we'll go more in depth into it later on. So now we have our, oops, not yet. So now we have our bullet controller right here. And what are we actually going to do with this bullet controller? Well, we want to be able to add force to it. So whenever this bullet leaves the barrel of our gun, we want it to move in a straight line forward. And whenever we want to add forces to our objects, we need to have a rigid body on them. Or whenever we want to make any game object come to life and interact with the world around it, we need a rigid body on it. And we've talked about rigid bodies before, we haven't gone in depth into it, so now I'm going to deliver on my promise. So what is a rigid body? So it gives us control of an object's position through physics simulation. The rigid body object will be pulled downwards by gravity without adding any code, and we can also apply our own forces on them. So what this means is that we can get any game object, we can add a rigid body to it, and now it will be subjected to the physics simulation that Unity has. Let's go and add a rigid body component to our bullet. And now in Unity, you already know how to add a component, so I'll give you just a couple of seconds for you to do that on your own. You go to bullet, pause the video if you know how to do this, time's up, add a component, and type in rigid body. Not rigid body 2D, that's used for the rigid body 2D. We are going to add a rigid body, which is used for 3D. And in here you can see that we have the ability to adjust the mass, we have the ability to adjust the drag, we have the ability to adjust the angular drag, we can remove gravity, which we'll be doing because we don't want our bullets to actually fall, unless you are going for a very realistic game. We can add a kinematic, and kinematic, if we hover over it, means that, well, it's not giving us anything, but kinematic means that it will not be subjected to the forces outside of it. And we have the interpolation, and this actually just allows for a better detection whenever it collides with various objects, and we can also change the collision detection to continuous. This is not necessary, but we can have it. We can also add constraints on it, so we can freeze the rotations on the X, Y, or Z, and we can freeze the position on the X, Y, and Z. We don't need to do any of these, and we have some information in here that gives us the speed, velocity, angular velocity, and etc. Great, so now we have a bullet, it has a rigid body. Next thing we need to do is we need to go ahead and add a couple of forces and a bit of velocity to it. So back in our code, first thing we need is we need to create a public float speed, or let's make it lowercase. So this will be a variable to control the force on our body. And then we need a reference, so a public rigid body, my rigid body. And now we need to understand which direction our rigid body is going to move. So if we go back into Unity, in here we have the speed, and we can add the rigid body right here. And which direction do we want our bullet to move? Well, obviously we want it to move in this direction, in the Z direction. This means we are going to be using the vector3 dot forward. So as soon as the bullet leaves the barrel, we want it to shoot out of this way. So back in our code, And we, of course, will be doing this every single frame. So inside of update, we are going to access my rigid body. And how do we actually get the velocity? Well, I've prepared a couple of documentations right here. You can go and look them up in Unity. So simply go to rigid body in Unity, and you should find this page right here. And you can see that there are a lot of properties. First of all, like I've showed you, you can freeze the rotation inside of the code, the position, use gravity, and velocity. And the velocity vector of the rigid body, it represents the change of rigid body position. So if we click on that, go in the Unity documentations, we can see that the velocity vector of the rigid body represents the rate of change of rigid body position. So we give a certain value to the velocity, and this will be the rate at which our rigid body changes positions. We can give a velocity to our rigid body. So my rigid body dot velocity will be equals to, of course, we are going to be using the forward of the transform. So the transform dot forward vector times the speed that we have. And because we are working on velocities, we don't need to actually add the time.delta time, which is very nice and cool. So let's save that and let's see if that works. Back in Unity, and let's see how our game, okay, so we can clearly see the bullet. So when we hit play, the bullet stays still. Why is that? Well, because obviously we haven't added any, we haven't added any velocity in here or speed. So let's move back a bit. So if we add a bit of speed, you can see that it moves slowly in the forward direction. So if we hit the scene, we can look at the direction that our bullet is moving in, and it's the forward vector. So let's get out of there a bit and let's go back and change, where is our bullet? So let's add a bit of speed. So let's make it 15, hit play, and now our bullet flies away. So it's starting to look like a really good bullet. And now, before we go, I'm going to issue you a bit of a challenge. So your challenge is to extract the methods. So extract the code for bullet flying from update into a separate method, and also extract the camera movement code sorry for that, in player update. So if you remember, inside of player here, we still have this mess inside of update, and in bullet we also have this kind of not such a big mess, but I wanted you to go ahead and learn how we can extract methods. So the way we do that is we actually take this code, we right click, we click on quick actions and refactoring. So hit that extract method, so hit extract method, and you immediately have the ability to name your method. We'll be naming it bullet fly. Hit enter, and now you have bullet fly. So now that I've showed you how to do this one, go ahead and extract the camera movement code in player update. Pause the video right now, go ahead and do the challenge. Okay, welcome back. So in player, we'll choose all of this code, we'll right click, quick actions and refractions, extract method, and we're going to call this the camera movement. Hit enter, and now we have player movement, camera movement as two separate methods, and our update looks extremely clean. So now we can look at update and know, okay, so what does our player do? He has movement and he has camera movement. Excellent. And this is the whole point of coding. You always need to have good habits at the start, so you always have clean cut code that is very understandable. Finally, we go in here in the masters, the uncommitted changes. You can see that we've created bullet material, we've created gun material, and by the way, whenever you see .meta, it's something that Unity uses in order to recognize its own files. We also added a bullet controller. And if we click on player, we can see that we've created a camera movement method. Everything in green is things that we've added, everything red, things that we removed. And let's stage all of that. Click on commit. Created my first bullet. Commit, go to masters, and I've made a huge typo in here. Not to worry about that. In the next video, we are actually going to be firing our bullets from the barrel and learning a very powerful tool in Unity that is called prefabs. So I'll see you in the next one. Welcome back, my fellow game developers. In this video, we are actually going to prefab our bullets and fire our bullets. So as you can see, our bullets are getting fired from our gun, or actually from a certain position. But as you can see, we still have a lot of work to do, and we'll get to that. But first of all, we need to create our firing bullets. So let's not waste any more time and let's get started. Okay, so first thing we need to do is we need to create a reference and a firing position for our bullet. So let's go into player, and in here we are going to go ahead and create a public game object, and this is going to be our bullet. And it's a game object because later on we are going to actually add the entire bullet, not just its transform. We want the entire bullet to be a reference to our player in order to be able to shoot it. Next thing we're going to do is we're going to create a second reference, which is going to be a transform this time, and this will be our firing position. So we want to determine a certain firing position from which the bullet will leave the barrel. Okay, now let's go into Unity and create our firing position. So this firing position will be a child of the head. So we'll right click on head, and we're going to create a empty game object, and we're going to move this empty game object in front of our firing position. So let's go ahead and try to put it just in front of our gun. So this way it will be shooting from our gun. And before we move on, let's go into our cube and just turn off the box collider. We won't be needing it for now. So let's name this the firing position, and this is where our bullet will be coming out of. Now, how are we? Well, let's go back. Let's see our player. So now we want to reference the fire position in here. So we'll simply drag the fire position here. Now we want the bullet, and you might say that yes, we have the bullet right here. But if we reference this bullet, when it shoots away and goes away, we'll want to shoot it again. And because we are referencing the bullet that is already in our scene, this is not going to work, and we are going to be using the same bullet over and over. So what happens when this bullet shoots an enemy and gets destroyed, or flies away after a certain time and gets destroyed? Well, then we won't have anything to reference. So what we need to do is we need to actually prefab this bullet. And let me tell you about prefabs. So prefabs, a prefab is a previously fabricated game object that we can use multiple times. So pre for previously, fab for fabricated. Let's go into more details. It's a template for a certain game object. Prefab system allows you to store a game object with all of its property. So what do we use it for? We can reuse a game object, configure it in a particular way. For example, our bullet is red, has a certain size of the collider. So when we prefab it, all other bullets created using this prefab will have the same properties of having this collider and this script, for example, also. It can be used in order to edit many objects at once. So let's say we want to edit this bullet, and instead of editing every single bullet in our scene, we can simply edit the prefab and all other bullets will also be edited. We can use the same objects in different scenes much easier, and this is what prefabs are. So let's go and prefab our bullet. And actually, prefabs are extremely hard to make. So the first thing we need to do is we need to create a folder. We'll call this the prefabs. And now comes the very hard part. In order to prefab this bullet, we will need to drag it right here. And that's it. I just wanted to build up a bit of suspense because this is very underwhelming. This is how we create a prefab. And the way you know that a certain object in your hierarchy is a prefab, well, you just simply need to look at its color. If it's blue, that means that it is a prefab, and you can find it in here. So now when we edit the bullet right here in the inspector from the prefab, the bullet here will also be edited. So now if we go into player, we can simply drag this bullet in here, and now it references the prefab. If we click on it, we can see that it's referenced right here. We can even delete the bullet from the scene. Now we can add as many bullets as we want, and all of them will move in the forward direction, but for now we'll delete them. Okay, great. So now we have our bullets prefabbed, we have them referenced. Next thing we need to do is we need to shoot them whenever we press a certain button. So let's go and update. We're going to create a method that is called the shoot, and later on we'll move this method to another class, but for now we'll keep it in player for the simplicity. You can see it has a squiggly line because shoot does not exist. So we click on this little lamp here and it gives us the option to generate the method. So we'll generate it. Of course, it's a void, so we'll delete everything inside. And now we want to be, well, how can I say this? Instantiating the bullet whenever we press a certain button. So which kind of button are we going to be pressing? We are going to be using the input system that we learned, but not to get axes. We're actually going to be using it to get a certain mouse button down. So if you go ahead and search for the get mouse button down in input, you can see that it returns true, which is a boolean. Okay, so we need to remember booleans are either true or false. It returns true during the frame the user pressed the given mouse button. So it returns true. And if we look down here, we can see that it uses an if condition in order to start the, or in order to check if we did press it, because as it says in the description, when we press it, it returns true. So that means that if we put it inside of the if condition, it will return true and this if condition will work. Now, we are not very familiar with if conditions, so let's delve deeper into them. What are if conditions? Now, if conditions are used in almost every single programming language, whether it be C#, Java, C++, or anything else. So this is the structure of an if condition. So if some condition that needs to be true is true, then the code inside the brackets will be executed. So this is why we are using the get mouse button down, because as you've read in the description, whenever we press one of the mouse buttons, we'll know which one later on, it will return true. And if we put it inside of these two brackets right here, and it returns true, a certain code inside of these squiggly brackets will be executed, and the code that we want to execute will be the firing of the bullet. And another thing that can be added to the if condition is an else if. So the else if takes some other condition that is true. So if the first condition is not true, we can write an else if, and if that condition is true, then we execute the code that is here. So if this condition is false, the code here is not executed, it will check else if this condition is true, then this code will be executed. But what happens if this code is false and this code is false? Well, we have a backup plan, which is the else. So if all conditions are false and none of them are true, then if it has an else, then this code will be executed. You can use if without an else if, and without an else. You can use the if with an else if, without an else, or you can use all three of them. So now that we know how if conditions work, let's go back into our code, and inside the shoot we are going to check if input dot get mouse button down, and we are going to use the 0, and the 0 means that it's the left mouse button, which is used for the shooting in most first-person shooter games, all of them I think. And in here we are going to be instantiating a bullet. Now again, we'll go back to the Unity documentations. So in here we can see that we can instantiate objects, and you have many iterations of this. So you can either create and instantiate from just the object that we presented, you can instantiate an object with its parent, or you can do these other things. And what we'll be focused on is this line right here. So we're going to be instantiating a bullet with an origin, with a position, with a rotation, which is quaternion, because we already know that quaternions represent the rotation. And I need you to focus very clearly on how instantiate works, because it's actually part of your challenge. So your challenge is to, first of all, read further the instantiate documentation to fully understand it. Then you'll need to instantiate the bullet. Now I've gave you a couple of hints. So first of all, you'll need to use the bullet prefab as an object, use the fire position for position and rotation. Now I know this video is a bit, has a ton of information. We learned about prefabs, ifs, conditions, and so on, but this is actually extremely simple, and I've gave you all the steps you need in order to complete this challenge. So don't be afraid, have courage, take your time, pause the video right now and go do the challenge. Okay, how did you get on with that? So first thing we'll need to do is we'll actually go ahead and instantiate. So instantiate, we'll open this up. First thing we need to add is the bullet as the game object. We then need to get the fire position, and this fire position is actually going to be the position from which we instantiate the bullet, and it's also going to be the rotation which the bullet will have. So whichever way we are facing with our fire position, which is attached to our head, that means it will be directly in front of our gun. So as soon as we instantiate the bullet, it will have the forward vector in front of it, and it will shoot straight forward. So back in here, our player has the bullet and the firing position, and now when we click on play, now our bullets might be a bit wacky, as you can see, and they are very wacky. So you can see that they are all over the place, and we don't want that. And that's because if we click on the bullet, we go down into the rigid body, we can see that we have these constraints in here. And let's go ahead and freeze the rotations on all the sides. Let's save that, and let's click back on play. And now our bullets should be, so our bullets should be a bit less crazy now. So as you can see, our bullets fly all over the place. So now our bullets are much better, and they're actually getting stuck to the wall because, as you can see, when they have a certain direction that they need to be going, so they are getting stuck on the wall. In the next video, we are going to actually be destroying our bullets, because as you can see right here, there are a lot of clones, and all of these affect our computer, and you can already hear the fans on my PC going crazy. So next video, will be delving deeper into what colliders are for these bullets, and we are going to be destroying them after they hit certain things just to save up on a bit of CPU. So until then, I'll see you in the next video. Welcome back, my fellow game developers. In this video, we are going to be destroying our bullets. And as we said, it's very important for the performance of our game. So as you can see, whenever our bullets hit a certain collider or object in the environment, they will get destroyed and will no longer be racking up in our hierarchy right here. But what we've also done, if we shoot the bullets into the air, you can see that they also get destroyed after a certain time. So let's not waste any more time and let's get started. Okay, so what's the problem? The problem is that, let's say we fired this bullet right here, and if we fire a ton of bullets, you can see that we have a lot of clones in the hierarchy. And this is what happens whenever we instantiate a prefab. It creates a clone right here in the hierarchy, and you can see it. Now, for now, all of these are not that big of a problem. But let's say we are playing a long level, and we've been playing at around 5 minutes of shooting, and all of these bullets are in our hierarchy. The performance of our computer will take a hit, and slowly but surely the game will start lagging and we will not be able to play it. So what should we be doing about all of this? Well, we need to be destroying our bullets whenever they hit a certain target or a collider. So what is a collider? We've talked about colliders. Let's add a bullet in here in our scene and let's take a bit of a look at it. So if you remember, we've added this collider, which is these green lines over here, and we can actually adjust the radius of this collider. And these colliders are actually what allow us to interact with the physical world around us. So let's look at our player right here. If we go to the body, you can see that it doesn't have a collider, but our player has the character controller and it has these green lines over it, and these represent the collider or the way which our player interacts with the world. Now, if we go, for example, for this block right here, we can see that it also has a box collider, and we can actually edit it with this button right here. Now, it's not very obvious, but if we move this little square, you can see that we can increase the size of our collider. So let's say this is our collider right now, and let's keep it like that, and let's go into our player, and I just wanted to make this just a little bit smaller, so 300, hit play. And now if we want to go up on this ramp, you can see that the bullet gets stuck on the collider that we've just created, and we cannot move towards it because the way objects interact with the world in Unity is through these colliders. So let's set this collider down and keep it just as big as it should be, not more. So now that you have a bit of understanding of colliders, what should we be doing with these colliders? Well, we want to, whenever our bullet hits a certain collider from the environment, we want this bullet to get destroyed and removed from the hierarchy. So how are we going to do that? Well, we have a certain method in here. So this is the documentation for the collider. You can go ahead and read all about it. It has many properties, many methods, and many messages also. And one of them is the onTriggerEnter. And this is when a game object collides with another game object, and this is exactly what we want. So if we go to the onTriggerEnter, we can see that in the description, well, it's when the object interacts with another object. And this method is called as soon as the object, which has the collider on it, interacts with another game object that has a collider on it. In Unity, we can see that for the sphere, or for the sphere on the bullet, we can make this a trigger. So if we click on here, this becomes a trigger, and this allows us to actually create the onTriggerEnter method in our script. So let's go to the bullet script, the bullet controller script, and just under the bullet fly, we are going to create the onTriggerEnter. So as you can see right here, we've talked about methods before, and we said that it can sometimes take parameters, and this is a parameter right here. And what is this other collider, you might ask? Well, this is the other collider. So let's say our bullet hits, let's say it hits this object right here. It hits the collider of this ramp right here. The other parameter that is sent through is the collider of our ramp. So what are we going to be doing here? Well, as we've said, we want to have our bullets get destroyed whenever they hit a certain object. So to destroy an object, we simply write here destroy, and we tell it that we want to destroy the game object. And whenever we write game object just like that, we destroy the game object that has the script of the bullet controller on it, which means the bullet in here will be destroyed. And before we move on, we need to make sure of one thing. Whenever we create a prefab and we want to apply it to the main prefab from our scene, we need to override. So up here, you can see that we have the option to override and apply all, and this will change. For example, it will tell us that we've changed the size of our sphere collider from 0.83 to 0.8. So we can apply all of that to the prefab, and now the prefab and all bullets created from this prefab will have this radius right here. So let's delete the bullet and let's see if that worked. When we hit play, we should see that whenever we hit the plane or we hit a certain object, the bullet gets destroyed. So now you can see that we no longer have all of these clones. Well, we still do, because some of them are actually flying away, and we will deal with this problem also. But now when we hit this brick right here, you can see that we no longer have a lot of clones around us. So when we hit the plane, well, some of them sometimes get through because of the speed, and you can see that our game no longer lags too much, and actually the bullets get destroyed. Some of them fly off. So what are we going to do about the bullets that fly off into the air? Well, we are going to create a timer for these bullets. So after a certain time of flying in the air, we are going to destroy them just like we did on the onTriggerEnter. Let's go ahead and do that. So first thing we'll need to do, we'll need to go into our script, and in here we are going to create another variable, which is a float, and you can name multiple variables on the same line if they are of the same type float. So this is going to be the bullet life, and this is the amount that, or the lifespan of the bullet that is being fired. And how are we going to reduce this bullet life? Well, in update, we are going to take our bullet life and we are going to be reducing it by the time.delta time that passes. And if you remember, when we put this minus right here, we mean that the bullet life is equal to bullet life minus time.delta time. So this is a comment right here for you to remember in the future how this actually works. So let's save that. And before we go, we need a way to always check on this bullet and see if it goes under a certain value, we want to be destroying it. And that's where your challenge comes in. So your challenge is to create an if condition. So create an if condition that checks if bullet life is less than 0. And if it is, you need to destroy the bullet. And make sure you do that in the update. So pause the video right now and go create an if condition. Okay, welcome back. How did you get on with that? Right here under the bullet life, So every frame we are taking away a certain amount of time, well, it's the time between each frame, and we're reducing bullet life by that time, and eventually if the bullet life is less than 0, so this means that it surpasses a certain threshold, we are then going to be destroying the game object. And let's save that. And back in our game, now let's go to the prefab of our bullet, and we have the option, where is it? We have the option to add a bullet life, so let's make it a 2-second. Let's hit play, and now let's say we fire our bullet, it gets destroyed when it hits a certain collider, and if we fire it into the air, we can see the clone right here after 2 seconds disappears. So 1, 2, disappears. Great. So now however we shoot our bullets, we can always be sure that they will all be destroyed and our computer will not take any hits and will not get impacted with lower frame rates. So with that done, I hope you enjoyed the video. In the next one, we are going to be adding more accuracy to our bullets. So I'll see you then. Welcome back, my favorite game developers. In this video, we've added a small point in the middle of our screen. And that's it. Well, no, actually, as you can see, we've just shot a very accurate bullet. So if you remember, before we created this video, when we shoot at a certain point in our world, the bullet just goes wherever it wants. But now, when we shoot, it goes exactly where we want it to go. So now we have much more accurate bullets. So let's not waste any more time and let's get started. Okay, so first thing we are going to do is we're going to create a crosshair in the middle of our view. So in here we want to create a small little button in front of us in order to have a point to point at. So in order to do that, we are going to be creating an image in front of our player. And in order to put an image in front of our player, we want to create a canvas. So let's go ahead and do that. In our hierarchy, we right click, we go to UI, and in here we can choose to create a canvas. So now we have a canvas right here with an event system, and this event system allows us to push certain buttons on our canvas. We can simply child it to our canvas. Now, where is our canvas, you might be asking? Well, this white huge line is our canvas, and if we double click on it, you can see that this is it. And you might be wondering, why is it so big? If you look closely, this is our little playground and this is our canvas. And whenever we want to be changing things in canvas, it's better to go and press the 2D right here. So when we press 2D, you can see that we can handle canvas much easier. Now, why is canvas this huge? This is a way for Unity to add images and things and easily modify them by making them this big. But don't worry about that, because let me just show you why. If we right click on canvas, go back to UI, and let's go ahead and add an image. So you might think that this image will be huge, but in fact, if you look in game, you can see that this is the image and it's actually a very small looking square. And this represents what will be rendered on the UI in front of us, and we'll be using it a lot later on. Now, before we start changing our image, we need to go to the canvas. We need to make sure that in canvas, instead of the canvas scaler being the constant pixel size, we want to scale with screen size. And in here, we can change the reference resolution. And because we're playing in the 1920 by 1080, we're going to do the same in here. So 1920 by 1080. And click on enter, and now we have our canvas always set to this resolution. Okay, great. Next thing we're going to do is we're going to click on the image that we have in here. we are going to double click and we'll call it the crosshair. And we want to make it a tiny circle. So we can go in here into the source image. We can click in here and we can actually change how our little image in here looks. So we're going to choose to have it as a knob. Oops. So as a knob, it's a circle. And let's go ahead and make it smaller. And before we do that, let me just dock the game view right here so we can see it. And the way we make it smaller is we hold one edge, hold down Alt, and then scale it down, and it will scale from all directions. And now you can see that it's much smaller. So let's go ahead and make it even smaller. Make sure that its position is always at 0. We don't want to be putting it on the side. We want it to be always at 0 right here. So 0, 0. And of course we want it to be a circle. So let's go ahead and make it maybe 25 by 25. So, and finally, let's change the color and let's make it black. So now in our game, let's see how that looks. Nope, I think it's still a bit big. So let's make it 12 by 12. Okay, so save that. This depends on your preference. If you want, you can even not make it a knob. You can make it a square if you like. So it depends on you, and you can make it as big as you want. So we hit play, and now we can see that we have this point right here. But as you can see, the bullets don't exactly go where we want them to go. They go flying off somewhere into the distance, and actually it's not as accurate as we'd like to have our bullets. So how are we going to change that? Well, we are going to be creating something called a raycast. So what is a raycast? A raycast is a ray that is cast from a certain position of your choosing. If you hit a certain collider in your world with the physics.raycast, it returns a true. So you should be immediately thinking that we are going to be using this inside of an if condition to check if we hit any collider. And let's explore the structure of a raycast. So raycast, first of all, has an origin, and it's going to be the starting point of our ray. We also have the direction of the ray. So just like we choose the direction of our fire point, the direction of the velocity of our bullets, we can also give the direction to the ray to follow in. We have the information that we get from that ray. So whenever we hit a certain collider in the world using this ray, it actually returns information about this ray, and this is going to be very important for us in the future. And we can also add a max distance to the ray that travels. So let's go ahead and create a raycast. So first of all, we want to go to our player, and inside of shoot, whenever we actually hit the mouse button, we want to check for a raycast. First thing we're going to do is we're going to create a variable that is of raycast hit type, and we're simply going to call it hit. Now we are going to create an if condition that checks for a physics.raycast, and in here, first of all, we're going to choose the origin. So what will be the origin of our raycast? Well, it's going to be my camera head dot position. So because we have our crosshair right in the middle of our screen, and the middle of our screen is actually the direction in which our head or the player's head is looking at. So let me put the canvas right here and make it smaller. So the position right here will be the direction in which our head or the head of the player is looking. So it's going to be the origin. Next thing, we need to choose the direction. So it's going to be the my camera head dot forward, and we'll need to create this out hit. And what out means, we didn't cover that. So what out means is that it puts out the information of the raycast into the variable hit that we've created up here. And finally, we need to add a max distance. Let's just make it 100 for now. Maybe we'll change it later on. And before we continue on, we just want to make sure that we have everything set up correctly. So we're going to create a debug.log, and this will print things to our command line. And what we want to be printing is we just hit, and in here we are going to take the hit or the object that we've hit with our raycast. We're going to access the transform, and we are going to get the name of it. Let's save that and let's go back into Unity and see if that works. So now when we hit play, let's see, for example, if we hit the plane, we can see in the console that we just hit the plane. And now if we hit this cube, I'm not sure what the number is on it. So when we hit the cube, it hits cube 2. Let's see, is that really cube 2? So where's our, oops. Let's go out from 2D, double click on game cube 2, and yes, it's working. So now you can see that we are hitting different objects in our world, and we actually have information about these objects. And this will be very crucial later on as we move through the game, because we want to know whether we're hitting an enemy, an ally, a big enemy, a small enemy. And as you can see, whenever we shoot in the air, we actually don't get any response, because at a certain distance this does not work. Okay, great. Now next thing we need to do is we need to actually make the direction of our fire position look at the center point. So that way we will be able to actually direct our bullets to the crosshair in the middle of our screen. Let's go ahead and do that. So back in our code, in here, instead of simply printing things, we are actually going to take our fire position and we are going to be looking at it. So we have the look at, which rotates the transform. So the forward vector points at the target's current position. So this is exactly what we want, because as you can see, the bullet is going towards or in the direction of the fire position rotation. And when we look at a certain object, the fire position will turn its rotation towards that. So this means our bullet will go in that direction. So now we take the hit, and in order to access it, we can actually use the point, which the impact point in the world space where the ray hit the collider. So we'll use hit.point. Now again, before we move on, we cast a raycast from the camera head position in the camera head.forward direction. We get the information from the hit, and it has a maximum distance. When we do get a hit position, we use the fire position to look at, which means we rotate towards the hit or the position on which we hit with the raycast, and we get the point, which is the exact point where our raycast hit. And then when we have the fire position looking at this point, we will actually instantiate our bullet, and it will be very accurate. Let's save that. And now back in our game, let's hit play. And now, as you can see, if we want to shoot at this position, if you look closely on the bullet, you will see that it actually goes to that exact same position. So now we have a very accurate gun. But there's still a small problem, and that problem is what happens when we shoot up in the air. So if there is no raycast, what will the bullets be doing? And the problem here is, now you might think that, okay, no problem, the bullet will just fly away on its own, but sometimes this will create a lot of errors, and we want to avoid that. So back in our game, in here, we're going to use the else. So this means if we don't get a true value, so we don't hit anything, else we want our fire position to be looking at my camera head dot position, and we're simply going to be adding a bit of my camera head dot forward times 50f. So let's say we hit a raycast, we don't register anything, so we have nothing to look at. So either we look at the hit point, Or if we don't find anything, we are going to be looking at the camera head.position, and we're going to be adding to it in the forward direction, just above the player at a certain direction. And now, if we go back to our game, this might not look as obvious, but in the long run, it will be much more evident. So as you can see, the bullet still disappears behind the crosshair. And now we have a very accurate bullet. Okay, great. So now we have accurate bullets. We make sure that if we don't have a certain hit position, we still have a direction to fire at. But there is still one small problem that may cause us, well, more problems in the future. So if we go closer to a wall, you can see that the bullet, instead of hitting a wall that should be in front of it, it actually also moves towards the center of our screen. And this is a bit cumbersome in the future when we'll start adding effects to our game. It will cause us a lot of problems. So we are going to face them before they get to us. So in here, when we cast a raycast and we actually hit something, we want to check for the distance between the camera position and the hit point. And if it's greater than a certain threshold, then we'll look at the position. So in here, we are going to create an if condition and check for the distances. Now, how do we check for a distance? If we go in here, we have the vector3.distance, and it returns the distance between 2 points, which are A and B. And what we want to check is the distance between my camera head and the hit point, and that is actually part of your challenge. So your challenge is going to be to calculate the distance. First of all, check for the distance between the camera position, which is my head, and the hit position. And then if it's greater than a certain float, which I'm going to go with 2f, use the if condition we learned in order to actually look at under only this condition. So pause the video right now and go do the challenge. Okay, welcome back. So if condition, we're going to access the vector3.distance, and we're going to use my camera head dot position, and the other value is going to be the hit dot point. And if both of these, or if the distance between these two is greater than 2f, then, and let me teach you a small trick in here, if you want to move this line up or down, simply hold down Alt and use the arrow keys, hit tab, and it will go into its position. So let's make this a bit cleaner. So now, only if the distance between the camera head position and the hit point, or the point at which the raycast hits, is greater than 2, then we will be looking at. Else, we will simply be shooting the wall. So let's get back in our game. Let's hit play. So now our bullets are still accurate, but when let's take a look down, and when we hit, you can see that the bullets don't directly go to the fire position, and they actually get destroyed before they get there. And the further we look up, you can see that they then become accurate when they are at a far enough distance. So great, now we have very accurate bullets. We are firing them at the appropriate distances. In the next video, we are going to be making our shooting much more exciting by adding particle systems. So I'll see you in the next one. Welcome back, my favorite game developers. In this video, as you can see, our player looks cool as hell. In this video, we are actually going to add a bit of flavor to our shooting. So now, not only do we shoot bullets, we also have this little muzzle flash in front of us. Of course, you'll have the ability to change up your muzzle flash depending on your preference, but we are going to have a lot of fun by learning the particle system and instantiating it whenever we shoot. So let's not waste any more time and let's get started. Okay, so right now when we hit play, we have our bullets, they are accurate, but the shooting is honestly a bit underwhelming. So for example, when we actually hit a surface, we have no idea that we did, and there is no indication that our gun is actually shooting something like a bullet. So the way we are going to change all of this is by adding particle systems, first of all for some muzzle flash, and then we are going to add another particle system for whenever we hit a certain object, it will create a bullet hole. So what is a particle system? If we right click right here in the hierarchy, we can go into the where are the effects, and we can create a particle system. Let's go into scenes and let's look at our particle system. So this is it. And you can see that it's a bunch of particles that get rendered in front of us. And these are actually 2D sprites that always look at the camera as we move around. So as you can see, if you've noticed that they are always moving around. And there are a ton of things that we can change in here on the right. But we want to actually go ahead and add particle systems that already exist and are much better than the ones that we can create on our own. Later on down the line in this course, we are actually going to be creating our own particle systems, but for now we are going to get them from Unity's asset store. Now, if you've never been to Unity's asset store, it's actually fairly easy. Simply go to assetstore.unity.com, and in here you can search for Unity Particle Pack. And when you find it, it's a bit of a big file, but don't worry, it's completely free. You have to click on Add to My Assets. When you do that, next step is to go into Unity, go to Window, and go to Package Manager. And this should open up a window somewhere, and this is the Package Manager where you will have all the assets that you've imported from Unity's asset store. Now, when you add your particle system asset, you should have this Unity Particle Pack 5x or something. When you have it, download it right here and then click on Import. So let's do that. I've clicked on Import. It will give you all of these. Simply make sure that you check all of them and then hit Import. And wait for them to import into your project. I will use the magic of editing again, and I will skip this boring importing part. It may open up a window just like this one, so if it does, simply click on Reload and don't worry about it. Okay, welcome back. So now that we have the package here imported, it's called the effect example. We can go ahead, right click on Package Manager and close the tab. We'll also close the project settings for now. And let's open up this file and see what we have in here. So these are all of the different effects that we have. And we have the blood, fire explosion, and a lot of other things. But what we want is we want to go to the weapons effect. We have the prefabs in here. And we have this bullet impact in here for flash big effect. We have impact for small flash effect. We have the impact or metal effect, and this is one that we want to have. We also have sand, stone, and other things. So we want the impact of the bullet on the metal. So what we do is we're going to actually duplicate this one. We're going to rename it to the bullet impact, and we are going to drag it into our own sets of prefabs. So drag this one right here into the prefabs. So now in prefabs we have the bullet and we have the bullet impact. Next we want the muzzle flash. So let's go into the example effect, and back in the prefabs let's get this muzzle flash, duplicate that, and we'll call it our gun muzzle flash. And again we are going to go into our prefabs and drag this gun muzzle effect into our own prefabs. Great, so now in prefabs we have the gun muzzle effect and the bullet impact effect, and we can actually go ahead and add these into our scene and simply look at them. Let's move this up and let's play it. So when we hit play, you can see that this is the muzzle effect that we are going to be playing whenever we actually shoot with our gun, and this will be the bullet impact. So let's see that again, hit play, and this will be our bullet impact. Very nice. Let's delete both of those from our scene, and let's go ahead and instantiate them whenever we actually need them. So back in our player script, in here, first of all, we'll need a reference. So we're going to create a public game object, and we'll call this muzzle flash. And we'll also need another one for the bullet hole. So now we have the muzzle flash and the bullet hole as public game objects. Back in Unity, we click on player. Let's go ahead and add the bullet impact to the bullet hole and the gun muzzle flash to the muzzle flash. Save all of that. Next thing we want to do is we first of all want to instantiate the muzzle flash whenever we actually shoot with our gun. So this will be part of your challenge, and your challenge is going to be to instantiate the muzzle flash. So first of all, review the instantiation in Unity documentation, instantiate the muzzle flash whenever we shoot, and make the muzzle flash a child of the fire position. And we'll see why in just a bit. So pause the video right now and go do the challenge. Okay, welcome back. So where should we be instantiating? Well, whenever we press the button. It doesn't matter if we actually find a raycast to hit or anything, we just want to instantiate it whenever we press the mouse button. So in here we are going to write instantiate, here it is, and then the origin or the object that we want to instantiate will be the muzzle flash, and the position is going to be the fire position, dot position, and the rotation will also be the fire position dot rotation. And finally, let me just show you why we want to have the fire position as the parent. So back in our game here, and now when we hit play, let's see if that works. Well, actually the muzzle flash, if you look on the hierarchy, is actually getting created, but it seems that nothing is happening. Why is that? Well, let's put this gun muzzle flash in here and let's look at it just a little bit. So first of all, we can actually play it and we see that it's actually real. But the first thing is that it's actually very small. So let's go ahead and make this maybe 4 by 4 by 4, and this will scale up our gun muzzle flash. Another thing that we need to do is that we need to actually click here on play on awake. And what this play on awake does is it actually starts playing as soon as we actually instantiate this one. So let's see if that makes any changes. And before we go, don't forget to apply all of that to the prefab that we've created. Delete the gun muzzle flash in our scene. And now, when we hit play, you can see that we have a muzzle flash. And why did I tell you that we need to make it a child? Because you can see that as we move, the muzzle flash is not instantiating on our gun, it's instantiating in front of it. So, and another problem that we need to solve is all of these gun muzzle flashes are not getting destroyed. And it's actually a fairly easy solution. So if we put it in here, or we don't even need to put it in the scene, if we scroll down, we can see that we have the option in here to stop the action, and it's currently on none. We can click on here and we can click on the destroy. So this will destroy the particle system from our hierarchy whenever it's finished playing. Let's apply that. And back in our game right here, or I mean in our script right here, let's go ahead and make it the child of the fire position. Save that. Now let's go ahead and try it again. And we should have a very nice muzzle flash. So hit play. And now we can see that even when we move, our gun still flashes in front of us. Very nice. Now you can adjust this muzzle flash as much as you want. You can make it maybe bigger, scale it up. Maybe you want to change the position of the fire position. Maybe you want, I'm not sure what you want to do, but anyways, let's go out of play mode. In the next video, we are going to be adding the bullet hole effect, and we're also going to be learning all about layers, because layers will allow us to have bullet holes only on certain game objects, not all of them. So until then, I'll see you in the next video. And before we go, let's go into the masters and let's commit our changes. So I've committed the, as you can see here, I added accuracy to my bullets, and now I'm going to tell it, oh, large file detected. Okay, so let's see. And if these files are too big, let's go ahead and ignore all of them. So right click in here and let's go ahead and ignore everything under the effect examples. So ignore everything beneath assets, effect examples, click on OK. And now we're going to stage all of that, commit all of that, and added muzzle flash to my guns. Okay, great, with an exclamation mark. So commit all of that, and I'll see you in the next video where we'll be adding bullet holes. Welcome back, my fellow game developers. In this video, we are going to be using tags to have different effects when we shoot things. So now when we shoot the little cubes that we have, you can see that we are creating bullet holes that are perpendicular to the surface. And this happens to all the cubes that we shoot, but if we shoot the plane, you can see that we are having these weird water leakages upwards in the air. So let's not waste any more time and let's go ahead and get started with learning about tags. I'll see you in just a bit. Okay, so first thing we want to do is we actually want to be instantiating our bullet holes. Now, if you want to take up this unofficial challenge, you can go ahead and do that. Okay, time's up. So let's go ahead and open up the script, and inside of here, whenever we actually get a certain raycast hit, we are going to go ahead and instantiate the bullet hole. So in here, if we also are at a certain distance, we are going to instantiate, and we're going to instantiate the bullet hole. It's going to be at the hit dot point. This is the position of the raycast hit, and we are going to use the quaternion. So quaternion dot look rotation. And why are we using look rotation? So you can see here that it creates a rotation with a specified forward and upward direction, and that's why we will need to use the quaternion look rotation for the rotation of our bullet hole, because we want it to always be perpendicular to the hit point on a certain surface. So we are going to use the hit dot normal, and the normal of the surface the ray hits. So normal means that it's the perpendicular axis of wherever we hit a point. This way the bullet hole will always be facing the perpendicular direction of any surface that we hit. So let's see that in action. Let's save that back in our game, and when we hit play, now whenever we shoot, you can see that we actually have a bullet hole that instantiates. Now honestly, these bullet holes are a bit small and they are not going away, or are they? Oh yes, indeed, they are going away on their own. How cool is that? Now I want to make these bullet holes just a little bit bigger, and maybe, let's say, maybe double the size, so 2 on the scale. Let's see if that looks good, just so we can see them better. So now, yep, these look a lot better. So now we have bullet holes. Nice. And great, so now we have these bullet holes firing every time we are moving. But the problem is, there are still things that we need to change about this, because later on, for example, let's say maybe we add some type of enemy, and we don't want to have these kinds of bullet holes on our enemy. We only want to have these bullet holes when we shoot certain kinds of objects. So maybe we don't want to have bullet holes on the floor. We only want to have bullet holes on the cubes and the environment around us. So for that, we need to use something called the tags. And what are tags? So if we go ahead and click on the environment, click on a cube or any object for that matter, any object in our hierarchy, even the main camera has a tag right here. You can see that it's the tag of the main camera. And cube, for example, the cube number 2 is untagged. So we want to create a tag for this, or a certain number of cubes that we have in here, and tag them as a shootable object. That way, only the shootable objects will get bullet holes on them. So let's do that. In order to create a tag, simply click here, and you can either choose one of the tags that are already available, or you can go ahead and add a tag. And we can see that there is a list of tags that is empty. We also have these sorting layers, and this is mostly used for whenever we are creating a game in 2D. This allows the sorting of layers, so what layer shows in front of which layer. And then we have these layers right here that we'll be using a lot in the future as the project progresses. So let's go ahead in tags. In here the list is empty. Let's create a new tag, and we'll call this the shootable. So now we have a shootable tag. And let's go in here and select all of our cubes without the plane, and let's go ahead and tag them as shootable. And let's save that. And now what we should be doing is we should go and instantiate our bullet holes only if the object that we hit with our raycast is a shootable tag or has a shootable tag on it. And for that, I'm going to issue you a challenge. So your challenge is to add a condition for the bullet hole instantiation. So check for the tag on the hit and make sure that it's on the hit point, and make sure that it's shootable. And if you feel confident enough, pause the video right now and go do your own research and find out how you can check the tags on game objects. Or if you want to have a little hint, let me give it to you. So you'll need to use the hit.collider.hit tag before you instantiate or inside of your if condition to check the tag. So now that you have all the necessary weapons, don't forget that the tag is a string. Pause the video right now and go do the challenge. Okay, welcome back. So let's go into our code. And in here, before we actually instantiate, we are going to create an if condition. We are going to first of all open up the brackets, get the hit. We are going to use the collider that is on the hit, and we are going to use the tag in here, and we're going to compare it to the tag on our game objects. So because this is a string reference, we need to go and make sure that we write it correctly. So shootable, we can't copy it, but we can remember it. So it's shootable. Back in our code, shootable, and let's move this instantiate in here. And a nifty trick that I'm about to show you is that whenever we have a single line of code under the if condition, we don't actually need these two squiggly brackets, and this will work for only a single line of code, because when we hit enter, now everything in here is outside the boundaries of the if condition. So let's make sure that all of this works. So we'll save all of that, and now we'll go into our game. We'll wait for this to compile. And as we remember, the environment, the plane is untagged, so whenever we shoot, we shouldn't get a bullet hole on the plane, but we should get a bullet hole on our cube. How cool is that? So With that done, we can do one final thing. Let's go into our scenes in here, or where are these? Where are the, okay, the effect material. And one final thing before we go, let's go ahead and add a certain particle effect to whenever we hit the plane. So let's go ahead and add a water container extinguisher. What is this one? Let's see. Well, actually the water leak. Okay, nice. So let's, or it won't let us, will it? Okay, so the way we do this, let's delete. This is the one, or is this the one? The container effect. Which one is it? The water leaking? Let's hit play. Okay, so this is the one that we want. Right click on this bullet impact water container, and we only want the particle effect. So let's go ahead and click on prefab and unpack completely. So now we can remove the water leak. And let's go ahead into our prefabs again. And in here, simply drag the water leak, and now it's a prefab. Let's go back into our player script, and up here we are going to add the water leak. Save that. And if you want to take this little challenge, you can also go ahead and create another tag, add it to the plane, and then if we hit the plane tag, if the hit collider has a plane tag or any name that you want to give to the plane, it will instantiate the water leakage. Okay, time's done. Let's go back in here. So player will have the water leak, and we'll go ahead and go to the plane in here. Where is it? So whoops, the plane. Let's add a tag, water leaker, we'll call it. So let's copy the water leaker, save that. Back in here, let's go ahead and create a if condition. So if the hit.collider.tag, or we can also use something else, which is compare tag, and open up the brackets in here and add the water leaker. So this is exactly the same as the one above, but it's just a different way of using this one. So we're going to copy this, instantiate, and paste it in here. And instead of the bullet hole, we are going to call the, what was it called? The water leak. So water leak, save that, and back in Unity. Let's click on the plane, make sure that it's a water leaker. So hit play, and let's see if that works. So yep, and it sort of works. And does it disappear? Nope, it's not disappearing. So make sure that the water leak gets destroyed. So in stop action, destroy, save that, and now we hit play. And I know it's not very logical to have the water leaking from the ground, but we just want to demonstrate the difference that we can make with these tags and the dynamic that it adds to our game. So in the next video, we are going to be adding a couple of enemies. Don't forget to commit your changes, and I'll see you in the next video. Welcome back, my fellow game developers. In this video, we are going to be adding a couple of spheres in the air. So I'll see you in just a bit. No, actually, we are adding these spheres because these spheres are our enemies. So whenever we shoot these, they are getting destroyed. And when we shoot other things, we create bullet holes. When we shoot the enemies, which are green and scary, not yet, but they will be later on, they get destroyed. So let's not waste any more time, and let's get started. Okay, so now we can shoot. We have bullet holes. Our shooting is really exciting and everything, but we still lack enemies to destroy. Let's fix that. Let's right click in our hierarchy and create a 3D object, and let's go ahead and create a sphere. So now we have this sphere in the middle of the air, and we are going to scale this little puppy up. So let's make him a bit bigger to where he's around 3. So yeah, 2.9, maybe 3. Let's make these a good, nice number 3s. Next thing we're going to do is we're going to create a material for this guy. So we'll, let's say, duplicate the gun material. We'll add it to this cube, and maybe we'll make him, what should we make him? Let's go ahead and make him green, because we still don't have any green colors. And let's go ahead and change the emission also to green. So now we have this bright green orb floating around. Should we make him whiter or darker? Let's keep him like that. Great, so now we have this enemy that is floating around. And what should we be doing right now? Well, we should go into our script and destroy any object that our bullet collides with. So before we do that, I want to duplicate this sphere, and let's make a couple of enemies right here in the air. And right click, create empty game object, and let's call this the enemies, and add these spheres under the enemies game object. So now they are all our enemies. Okay, great. Actually, let's move this one here and move this one over there and this one over here. Okay, great. Now we have our enemies in our playground. I'm just giving them a bit of a random feel. Great, so now we save that, we hit play, and we have these enemies in the air right now, but as you can see, nothing happens. Our bullets simply disappear. So what we want to do is we want to go into our scripts and go to our bullet controller, and in here on the on trigger enter, before we destroy the game object, we want to destroy the other .game object. So now the other is the other collider that we collide with, and we take the other collider, we access the game object on it, and then we destroy it. So now back in our game, we hit play, and let's see, so oops, let's hit this, and whenever the bullet collides with our enemy or these spheres, it gets destroyed. But there is just a little small problem. It's not very noticeable or anything, it's not game breaking, but the problem is that when we hit our ramp and everything around us, the world also disappears. So yeah, that's not such a good idea. So what we want to do is we actually need to give you a challenge. So your challenge is going to be to destroy only the enemies. So if you're feeling up to it, even before I show you the challenge, from only this one you should get a feel of how you need to build this. If not, you need to create an enemy tag. You need to check for enemy tag whenever you collide with a target, and I'll give you a hint that we've already done, but you'll need to maybe use the hit.collider and compare the tag. So use both of these methods in order to understand which one you like more, whether it's the hit.collider.compare tag or accessing the tag and comparing it with a other string. So pause the video right now and go do the challenge. Okay, welcome back. How did you get on with that? So let's go ahead and add a tag, create a tag in here, and this is going to be the enemy. So enemy tag, let's go to our spheres, select all of them and tag them as the enemy. Very nice. Now back in our scripts in here, we are going to create an if condition, and we're going to get the other dot compare tag. So compare tag, and in here we are going to create the enemy. But before we do that, there is something that I did not explain in the previous video. So the other dot tag, I actually written these two equals equals. Now, some of you might have been confused. Why are we not using a single equal? Well, when we use a single equal, if we hover over this, you cannot convert, well, this is not the problem. The problem here is that whenever we write a single equal, just like in here, we are actually assigning a value. When we write two equal, these two equals equal, it means that we are comparing them to each other, and if they're the same, then we are going to return true or false. So with that cleared up, let's go ahead and create the enemy. Let's just keep it like that. No worries, both of these methods work. And because we only have a single line, we will not need to add brackets. Or if you feel comfortable with adding brackets, you can of course do that. So we save this, go back into our game, we hit play, and now we shoot the ground, it doesn't disappear, and when we shoot the enemy, they actually disappear. Now the problem is, you know how guns work. Whenever you shoot an enemy, it doesn't take like 5 seconds before the bullet actually reaches the enemy. We need to make our bullets faster. So we go into the prefab, click on bullets, and the bullet speed should be maybe 300. So we hit play, and now we shoot our bullet, but whoa, what is happening? Why is our enemy not disappearing? Are we not hitting the enemy? Yes, we are. Now he disappears. But what happened? Why was it sometimes taking so long? So the problem is, of course, when we have the sphere collider on our bullet, we have the sphere collider also on our enemies. But the problem is, because of the speed of our bullets, the way Unity works when it has colliders and rigid bodies on it is that it actually does mathematical calculations while our rigid body or the bullet is moving, and as soon as it hits a collider like this one, it starts calculating what should it do and how did these two colliders interact with each other. Now the problem is, when we have very fast objects in Unity, this does not work properly. So I'm going to teach you a different way of destroying our game objects. It's not very hard, but we've done something similar already, but it's a different way, and you have the choice to choose. Okay, you have the choice between either using this method of using the onTrigger enter, or using the method that I'm about to teach you. And in here, we are going, whenever we actually hit an enemy or hit with the raycast, we are going to check if we hit the enemy or hit an object that has a tag on it. So in here, whenever we actually hit something with our raycast, it doesn't need to be even if it is very close, we will start with here. So if we go ahead and get the hit.collider.compare tag, and I hope I'm not confusing you with the different ways we are using the tag in here to compare it. So enemy, and below it we are going to destroy the hit.collider.game object. So we'll save that, and on the bullet controller, let's just tag both of those lines. Save that back in Unity. Wait for this to compile, and now when we hit play, we can see that the bullet is very fast, just like normal bullets are, and when we hit these objects, they get destroyed immediately. So it depends on you. Which one do you want to do? Do you want to have your bullets actually destroy the enemies? This will cause it to have, you'll need to make it less fast, or do you want the raycast to be destroying the enemies? This way you can actually create realistic bullet movement. It depends on you what you want to do. Maybe you can find a good threshold in between them. I personally recommend using the raycast and making the bullets very fast, because later on we'll be adding realistic weapons with realistic bullets, and it doesn't really feel nice when you see the bullet slowly moving towards your enemy. And it's also less accurate, and when real games are made, AAA games like Call of Duty and other games are made, the bullets are actually not the ones destroying the enemies. The raycast is destroying the enemies. So with that said, I hope you enjoyed this video. I hope you enjoyed this shooting section. In the next section, we are going to be creating advanced movement with sliding, crouching, jumping, adding gravity, and all of that fun stuff. So I'll see you there. Welcome back, my fellow game developers. In this video, we are actually going to be adding some gravity. So remember the good old days when we used to climb up these ramps and we would float around? Well, now that the fun is over, so when we step down, we actually fall. And remember when we could have walked around in this plane and not worry if we fall down? Well, now when you walk down the plane, you start falling down. But no worries, adding a bit of rule and constraints to the game actually sometimes makes it more fun. Just look at Dark Souls and how hard it is and how fun it actually is. Anyways, let's not waste any more time and let's get started. Okay, so currently when we hit play, our player moves up the ramp, and when he tries to go down, well, he actually stays in midair, and you can see his shadow right here. So what we want to do is we actually want to start setting our player down whenever we go up a ramp or try to do anything. So our goal is to add gravity to our player. Now let's go ahead and talk about what gravity is and how it works. So this is how gravity works. I'm not sure if you remember this formula from high school, but this is the difference of the distance, which is y, which is on the y-axis, and it's the g, or 1/2 times g, and g is the gravity times d to the power 2. And we have all of that. We have g as the power of gravity on Earth, which is 9.81, I believe. It's a long number, but 9.81, and then we have t, which is time dot delta time each and every single frame. So let's go ahead and implement this formula in our code. So first thing we're going to do is we're going to create a reference in here to keep track of the velocity of our player. So we're going to create a public vector3, and this is going to be the velocity. Next thing we're going to do is we're going to add this equation or apply this equation in the player move. So we go to the player move, we double click on it, and we can actually scroll down and see where that is. And after we apply the movement from our inputs, we then go and get the velocity. We access click.y, and this enables us to access the y component on the vector. And we're going to write in here plus equals, because the gravity increases as we fall down, physics dot gravity dot y, and this means that it's the actual physics from Unity's engine. So if we hover over it, it's the Unity engine dot physics. We access the gravity, and in here we can actually multiply this by mathf dot pow meaning that we can add power. So you can see here that it returns f raised to the power p. And what should f be? Well, it's going to be the time dot delta time raised to the power of 2. Very nice. We will not be bothering with adding the 0.5 right now. It's not that big of a deal. And next thing we're going to do is we're going to access my controller, and we're going to add this to the movement of our player. So now my controller.move is also affected by gravity. So let's go into Unity and let's test this gravity out. So let's go ahead and click on play. And I just noticed something before we continue. This gun material.1 is the material for the enemies. So let's name this the enemy materials. I hope nobody noticed that. I'll just do it without anybody seeing it. So we'll save that, we'll hit play, and now whenever we walk, we move up this ramp, and when we go down, let's click on player and see the velocity. So it's increasing, and now we fall down. Very nice. And if we move out from the edge, ooh, we start falling. But there is something really wrong here. If we click on play, we can see that because the velocity right here is a vector 3, so we have the 0, well, we have the x, the y, and the z, but the y keeps increasing even when we stop moving. So even if we're standing still, the velocity keeps on increasing and increasing and increasing, and this makes the falling down very fast and not very natural. So we'll need to be able to reset our gravity whenever we actually start standing on the ground. And this is going to be your challenge. So your challenge is going to be to reset gravity if the character is grounded. So find the method that lets you check if your character controller is grounded. This will be a research-based challenge. You'll need to go out of your way and actually try to find a method that I have not taught you yet. So reset the gravity velocity of the character controller. But this should be if the character controller is grounded, and I'll just give you a hint of what the velocity should be. It should be physics.gravity.y times time.delta time. Now it doesn't need to be this exact value, but you can use this pretty well and it works. So pause the video and then go ahead and do some research, find out what you need. Everything you need is right in here. So I'll see you in just a bit. Okay, welcome back. So first thing we'll need to do is we'll need to check if our character controller is actually grounded. And if you've done your research, you would have found that my character controller has an option to check if he is grounded. And was the character controller touching the ground during the last move? So was he grounded? Yes or no? And if he is grounded, we are going to take this velocity and we'll access the y component on it, and we're going to make it physics.gravity.time. Oops, no, I meant .y times time.delta time. So now we have the velocity right here getting increased slowly but surely with the right physics equation for gravity. And then if my controller is actually grounded on the ground, we will stop all of this and then we will reset it. Now it doesn't have to be the physics gravity.y times time.delta time. I've just made it this way in order to make it much more realistic. You can only set it to, let's say, -1 or something like that. But let's go ahead and test this out and see if it works. So when we hit play, we should see that our gravity is at -0.1, which is fairly reasonable. And now when we fall down much more slowly and reasonably. And let's take a look at this y right here. So when we actually start falling down, this should be increasing. So it increases, but then it resets when we hit the ground. So again, it resets when we hit the ground, and the falling is actually much nicer. But if you can see right now, when we try to fall, it's more like gliding around, and we don't want that. We want a way to be able to actually control our gravity. So let's go ahead and create a variable that will enable us to modify our gravity. So we'll open up our player script. We'll move up in here, and let's just go ahead and separate this and call it the adding gravity. And under here, we are going to create a public float, and we'll call it the gravity modifier. So we'll have a gravity modifier in here that is public and we can control. And down here, we are going to go ahead and multiply our velocity by the gravity modifier. Let's save that. And now back in Unity, we have this gravity modifier right here. So now because it's 0, this will not work at all. I think he will not be even floating. Oops, well, he does float, but if we multiply it by 5, he should start falling down much faster. Yep, there we go. So now gravity works stronger on our player whenever he falls. We can even make this maybe 10 if you want. So this way the gravity will be much snappier. So now our player falls faster to the ground. So this will be a challenge for you, an extra challenge to go ahead and modify your gravity as much as you feel you want your game to have. So I'll just keep it at around 30, and I think that's a good gravity modifier. So I hope you enjoyed the video. In the next video, the obvious progression is, now that we have gravity, to start defying that gravity by jumping. So I'll see you in the next one. Welcome back, my fellow game developers. In this video we are going to be defying the gravity. We are going to be defying the force of gravity by adding a jumping mechanic. Now it's going to be a more of a hopping style jumping, so we are going to be learning a lot of things about layers, jumping, formula for the jumping. So let's not waste any more time and let's get started. Okay, so first thing we're going to do is we're going to be opening up our script, and in here, after we move our camera, or it doesn't matter really, we are going to create a method called jump, and we're going to create a void jump, and we're going to open up our brackets, and in here we are going to take a certain input from the jump button. And when we get this input, we are going to be adding velocity in the y direction. So what should we be using? Well, we have this little method in here that is called the input.getButtonDown. And if you read the description, you can see that it returns the true during the frame the user pressed down the virtual button identified by the button name. So they are asking us for a button name, and thankfully we do have in Unity. If we go to the edit, we look for project settings, we have this jump button right here that is used with the positive button being space. Now we have another jump button right here, and usually this second jump is used with a joystick, so it's for a console or some kind of thing. So now we have the jump. Let's go back into our game or into our script, and in here we are going to write if input.getButtonDown, get button down, and it's going to ask us for the string name. So we'll go into because it's a string reference and we can copy it, so we'll copy this and we're going to paste it in here. And what are we going to do in here? Well, we're going to add a certain velocity in the y direction, and it's going to be equal to the jump height. And this jump height will be a variable that we are going to create up here. So in here, we're going to create a public float jump height, and let's go ahead and set it to 10f. I'm not sure how much it should be, but for now, we'll keep it at 10f. Very nice. Now let's go back into Unity. Let's go ahead and close this input manager, and let's hit play and see if that worked. So now we can shoot, we can move around, we also have gravity, and when we press the space bar, well, I think our jump is just a little bit exaggerated. So we're going to fix that. So if we go into player, let's reduce this to 2. And we jump, and yeah, this seems more reasonable, but there are still many problems. So first of all, it looks weird. Second of all, while we're walking, and sometimes the jump doesn't work, so when we hit space it doesn't work, so this is a second problem. And the last problem, and the most game-breaking one, is that we can jump and keep jumping whilst pressing the spacebar into infinity. And then when we stop, we drop down. So there are a couple of inconsistencies with our jumping. So first of all, we want to address the ability to jump infinitely. And this will be addressed using something called an overlapping sphere. So what is an overlapping sphere? Let me just show you here in the documentation. So physics.overlapSphere, it has the parameters of the position or the center of the sphere. It has a certain radius, which is the radius of our sphere, and it also can take a layer mask. So this layer mask allows it to interact only with certain types of layers. And what does it do? It actually returns an array with colliders touching or inside the sphere. So what is an array? Well, we haven't talked about arrays yet. We'll go much deeper into them, but for now, just as a simple explanation, arrays are like a table that has inside of it values, and this physics.overlapSphere returns these values or these objects that are inside of the sphere. And why are we using overlap sphere? Well, because we want to count the objects that this overlap sphere is touching, and if it is touching something under the layer ground, then and only then will we allow our sphere or allow our player to jump. So if he's in the air and he's not touching anything that is underground, then he will not be able to jump. So we'll check how much are inside of these arrays. If nothing is there, we will not be able to jump. With that said, let's go ahead and start creating a couple of variables for all of that. So back in our game, let's move this and let's call this the jumping section. Just so we have a bit more organization, we'll also name all of these later on. But for now, we're going to create a private boolean, and it's going to be called ready to jump. Very nice. So now, if we press the jump button and we're ready to jump, then we will be able to jump. So whenever we want to add a second condition next to whatever condition there here is, we can add these little and marks. Next thing we're going to do is we're going to, before we create anything here in Unity, we are going to add the center of our sphere. So this is going to be an empty game object that's called the ground, and it's already at the bottom of our player. So this is where our sphere is going to be created. So we can even move it down just a little bit. And in here, the sphere will be created around this game object, and it's going to be checking for the ground. Let's save that back in Unity, and let's go ahead and get a reference to it. So public transform, and we'll simply call it the ground. Another thing we'll need is the mask. So we're going to create a public layer mask, and it's going to be called the ground layer. And finally, we'll also need to create a public float ground distance. So ground distance, and we'll set it to, let's say, 0.5f, just for now. Okay, great. So now that we have all of these, next thing we'll need to do is we'll need to go ahead and create a layer for the ground and set all of the objects in our environment to this ground, and it's actually part of your challenge. So your challenge is to create a ground. First of all, go ahead and create a ground layer. If you remember how we created layers, let me just show you if some of you forgot. So just like we created tags, in here we can go to the layer, we can go to the edit layer, and you can see that we have the option to create tags, sorting layers, and of course the layers right here. So create a ground layer, set all the objects under environment to the ground, and assign the ground layer to the layer mask in the player's inspector. And if you want to go even further, you can go ahead and implement this overlap spheres. Now you might get a couple of errors, you might not understand what's going on. Don't worry about it. Just get to a certain point where you actually add this physics.overlap layer if you want to take up that extra challenge. But for now, go ahead, pause the video and create a ground. Okay, welcome back. How did you get on with that? I hope you are taking the time to do these challenges because they are very important. So now we have the ground, and when you do the challenge, it gets ingrained into your mind even when you fail. So back in our player, and now we need to give it the ground transform, and the ground layer needs to be set to the ground. And what else should we be doing? And nothing, we're done here, I believe. Now back in Unity, I hope you tried to create the overlapping sphere. So what is going to be the overlapping sphere? Well, we're going to create physics.overlap sphere, and in here, first of all, it will need the origin. Of course, we have the ground.position as the origin. We need the radius, so it's going to be the ground distance. And finally, it will need a layer mask, which is going to be, of course, the ground layer. Now, if you got to this point, very nice, I congratulate you. What should we be doing next? Well, now we have this overlapping sphere and within origin, a certain radius, and only checking for the ground. So this will return some kind of an array, or the amount that we have inside of our sphere. So we want to check if the length of this array, so if the length of objects, if the amount of objects inside of this sphere is greater than 0, that means that we are touching some kind of ground, then our ready to jump is going to be equal to true. So this means that it's assigned the value of this condition right here. And if it's true, this returns true, then we are ready to jump and we press the button and then we jump. But if we don't have anything inside of this overlapping sphere and the length is less than 0, then ready to jump will be equal to false and we will not be able to jump. Very nice. Let's go ahead and test this out and see if we forgot to save all of that. And now back in Unity, we are going to hit play and let's see if we can multi-jump. So we jump, and we are not jumping at all. So okay, so the huge problem that we made, and I hope you didn't make the same problem, it was even in the challenge. We need to set all of our objects in the environment to the ground. You cannot believe how long that took me to understand. But as you can see, even the great instructor Michael makes mistakes. So now, okay, so now we should be able to jump very high. Okay, but because the jump is reset, let's put it back to 2 or maybe even to 1 just for testing. So we hit play and now we jump, and we cannot jump multiple times unless we are on the ground. Now there are still a couple of things. First of all, the jumping is weird for some reason, and the second thing is that whenever we are moving, sometimes when we hit the space bar, it's not responding very fast. First of all, let's address the problem of the weird jumping. Now, after the challenge, we have the height affected by gravity. So what is the actual velocity that we want to add when we jump? This is the formula. So velocity is equal to the square root of -2 times the jump height that we want times the gravity. Now, some of you might be looking at me or at this formula and thinking, whoa, -2 inside of a square root? That never happens. Well, because gravity is -9.81, this means that this entire value in here is positive. That means we can use the square root. Mathematics never lie. So let's go ahead and implement this formula back in our game, back in our script. Instead of the velocity.y being the jump height, it's going to be the mathf dot square root. And inside of the square root, we are going to use the jump height. We're going to be multiplying it by -2f. And we're going to be accessing the physics.gravity.y. Okay, very nice. And as a final touch, we are going to make it frame rate independent. And this will, of course, change the value of our jump height. Now, as a final step, or let's just test this out and see how it works. And I think we'll need to make the jump height at least 50. So we hit play. And now when we move, you can see that our jump is much more natural. Let me make this 100, just so we actually jump. So our jump is much more natural right now. But the problem is still that we are not jumping every time we want. And it's because we have this velocity in here, so we are setting it. But as we are updating in our player move, we are also changing the velocity. So there is a conflict between the velocity that we're adding in the jumping and the velocity that we're adding right here. And sometimes the velocity of the jump is getting overlapped. So the way we fix this, we simply in here, my controller dot move, and we update the velocity on our character controller. And now when we hit play, we should see that when we press the play button, we move, and as soon as we press the space button, we actually jump. And as a final touch, let's make this 100. Let's save that. And let me just show you a small experiment that you can make. So we'll choose this cube, we'll make it a default player, we'll hit play, and now we can jump on the plane, jump on this ramp, but when we get to this cube, we cannot jump. So very nice. Now that we know how all of that works, we can go ahead and finally go to our source tree, add all of our uncommitted changes, and added the ability to jump. Very nice. In the next video, we are going to be creating a crouching mechanic. This changes back to ground, save all of that. We are going to be adding the crouching mechanic, and we're going to be playing around with the scale of our player. So I'll see you in the next video. Welcome back, my fellow game developers. In this video, we are going to be implementing the crouching mechanic. So let's open up these scenes right next to the game, and when we hit play, you can see our player. So he is normal right now, but when we press the left Alt key, you can see that he turns into a little munchkin. So now we can move around, and as we're moving, we can start the crouching. And if you've noticed, our speed is also reduced whenever we are crouching. So let's not waste any more time, and let's get started. Okay, so it's time to start crouching. Now, how are we going to do this? So if we go into player, you can see that in here we have the scale, and we actually can manipulate the scale of our player, and that's exactly what we are going to do. So now you can see that the player has a scale of 1 on the x-axis, y-axis, and z-axis. And what we're going to do is we're actually going to take the scale on the y-axis and reduce it to half. So now we have this cool small little guy, and this way we are going to be able to crouch and move under certain objects, like where's our limbo right there. If you remember, we created it at the beginning of the course. So great. We are going to be manipulating the scale of our player and dividing it by half. So first thing we're going to do is we're going to go into our player script. We are going to create a section in here for the crouching, and under it we are going to create our first private vector3, and this is going to be our crouch scale. And this crouch scale is going to be equal to a new vector3, and on the x-axis we're not going to change anything. On the y-axis we are going to make it 0.5, and on the z-axis it's going to stay at 1. We'll save that. Next thing we want to do is we want to get the player's scale initially before we start crouching. So we'll create another private vector3, and we'll call this the player scale. And now what we are going to do is inside of the start method, we are going to set our initial player scale. So at the start, we're going to create the or get the variable of the player's scale, and we're going to access the transform of the player and get the local scale from there. So now we have the actual scale at the beginning. Okay, with that done, next thing we're going to do is we're going to, in update, create a method that is the crouching. So crouching, and we are going to generate this method. So generate the player crouching, and we're going to delete whatever this is in here. And how are we going to get the crouching? Well, we are going to be using the left alt key, and this is the standard key for the crouch. Now the problem with using the left alt key is that we don't have any button for this. We are going to use something called a key code, and a key code is a way that enables us to map the physical keys on a keyboard. And we have two types of keys. So we have the input.getKey down, and we have the input.getKey up. So what's the difference between them? It's a difference that might be very familiar. So when we get the input.key down, this returns a true during the frame the user starts pressing down the key. So when we start pressing down the alt, we want to be crouching, and the key is identified by a name that I will show you in just a bit. Another thing that we can do is another option that we have is the get key up, and this returns true during the frame that the user releases the key. So whenever we release the alt, we want our player to stop crouching. So let's go ahead and do that. We're going to create two methods that are going to be the start crouching and the stop crouching. And we're going to put them inside these two if conditions. So the first if condition is going to be the input.getKey down, and we're going to access the key code, and this will enable us to get any key that we want. So if we start writing left, you can see that it gives us all of the options on the left. So left Windows, left Control, left, I'm not sure what Apple is, but anyways, left alt is what we need. And in here we are going to start crouching, and under it we are going to create another if condition, and in here we are going to get the input.getKey up using the key code left alt, and we are going to stop crouching. Okay, great. So now that we have all of this established, the next natural step is to actually go ahead and create the start crouching. So up here, let's go ahead and generate this method, and let's go ahead, and in here we're going to be implementing the crouching mechanic. And now let's generate the stop crouching. So we'll generate this method also, and let me just move the stop crouching under the start crouching. It just feels more natural. Okay, great. So now we have these two methods, and what are we going to do inside of them? Well, it's very simple. We are just going to take the local scale, so the transform.local scale will be equal to the crouch scale, and when we stop crouching, we are going to take back our transform.local scale, and we are going to set it back to our original player scale. Okay, great. So let's go ahead and test this out in Unity. Now there will be just a little bit of a problem in here, and I'll just show you what that is. So when we hit play, and you can see that whenever we hit the Alt key, our player gets a lot smaller. And I just wanted to show you how all of this works. So our player has his gun, his cool glasses, and when we click on the Alt key, he becomes a little small leprechaun, and he actually can also shoot. So the problem is, what I wanted to show you is that whenever we are holding the Alt key and press the W, it is a shortcut to the Windows, and now we have to stop using it? Well, we can use the C key if you want, or you can always make sure that you hit the W key before you start crouching. Okay, great. So now we can move around. We can hit the Alt key, and we also open assets when we hit Alt and A, but no worries about that. And maybe we should make this limbo just a little bit smaller. Now, the other thing that we want to change, let me just dock the game back here. The other thing we want to change is whenever we are crouching, we want to actually make our speed just a little bit smaller. So instead of having this, the speed as a normal speed, we want to have it reduced, and we want to have a crouching speed whenever we are crouching. And it's going to be part of your challenge. So your challenge is to control the crouching speed. So first of all, create a crouch speed variable, just like we did with the normal speed. Then you'll need to create a boolean that checks if we're crouching. So you'll need to create a boolean, and you'll need to change it based on whether we are crouching or whether we are no longer crouching. And then you'll need to multiply the movement by crouching speed and not the normal speed using the else if condition. So create a variable for the speed, create a boolean for the crouching, and when we are crouching, so you'll need to create an else if condition inside of the player movement, and when we are crouching, the speed or the movement will be multiplied by the crouching speed. Pause the video right now and go do the challenge. Okay, welcome back. So first thing we're going to do is up here, or you know what, let's keep it down here. We are going to create a public float please, and we're going to call this the crouch speed, and it's going to be equal to 6f just for now. And the next thing we're going to do is we're going to create a private bool, and we're going to call this the is crouching. And for now we're going to set it to false, because at the beginning of every game, of course, the crouching will be false. So is crouching is equals to false. And now whenever we are crouching, we are going to set the is crouching to true. And when we stop crouching, we'll simply set this is crouching to false. And finally, in where's our player movement? So in here, we can see that we are always multiplying the movement by the normal speed. Well, not anymore, because we'll create an if condition in here, and we're going to check if is crouching, or if crouching is crouching is true. Then in this case, our movement, let me just copy all of this, copy this line. Our movement is going to be equal to the movement times the crouch speed. Else, we are going to use the movement times the normal speed. And we're going to save all of that. Let's go back into Unity. Let's hit play. And now we should see that we have a crouch speed somewhere in here. So crouch speed is 6. So now we move with a certain speed. And when we start crouching, you can see that our movement is much slower. And that's exactly what we want. So you know, whenever you're playing video games, whenever you start crouching, your player's speed is actually reduced. And it's very normal and realistic. And now the thing that we need to fix is actually whenever we are crouching, you can see that our gun is also being squished and also getting divided by 2. And this is not a good thing, because later on we are going to be adding really cool guns, and these guns are actually going to be squished also, which is not what we want. So in the next video, we are going to separate the crouching or the scaling down of our player from the guns and all of that. So I'll see you in the next video. Welcome back, my fellow game developers. In this video, if you remember in the previous video, whenever we crouched, our gun became much smaller, but now when we crouch, our gun stays the same size, and we can see these little lines in here. We'll fix that maybe later on, but for now, our gun stays the same size, yet we are able to crouch and go under certain objects, and our speed is reduced. So let's not waste any more time and let's get started. Okay, so what's the purpose of this video? During your game development journey, or when you actually become a game developer, you will notice that sometimes there are different solutions to your problem. Or whenever you create a certain game mechanic, there are problems that you need to fix. And this is exactly this is the case. Initially, I wanted to simply go ahead and create only this video, but now as I went through this and I found this problem, I actually wanted to take you through the process of fixing various game mechanics just like this one. So right now, if you remember from the previous video, whenever we crouch, you can see that our gun gets slimmer, and this is not good. So this is a problem created by a mechanic that we've added. So what are we going to do about this? Well, instead of reducing the player size, we are only going to be reducing the body of the player, and then we are going to move the head down, and finally we are going to reduce the height of the character controller. Now, all of these are discovered through experimentation, but I'm not going to be sitting here and experimenting with you. I will show you how we go ahead and think about all of that. So, first of all, we take the body. We want to reduce, of course, the scale of our body by half. When we do that, we'll notice that our character controller height is still the same size and is still interacting with the limbo right here. And before we continue, let me just move this limbo a little bit up so we can actually make this bigger. And let's also increase the size of this cube right here. Okay, great. So now we have the body getting reduced by half, and we have the controller's height getting reduced by half. And then we have the head. So because the head is not attached to the body, when we reduce the scale of the body, the head will stay in its place. So what we are going to do is we'll actually also move the head down. Great. Now let's get started with all of that. In our script, we are going to go ahead and where's the crouching? So instead of the player scale, we are going to call this the body scale. And this is a great opportunity to show you something really cool. So let's say we want to change the player scale to body scale. How can we do that and change also all of the different references in here? So we'll need to change this one and this one in here and this one in here. So let's say we have 100 references. How do we change all of them? Well, very simple. Double click on the player scale, hit Ctrl RR, and now this will allow you to modify this. So we'll name this body scale, and all the references are changed also, and we'll apply all of that. Next thing we're going to do is we're going to create a reference to the actual body. So in here we are going to create a public transform, and we'll call this my body. And under it we'll also create a private float initial controller height. So now we have the initial controller height, we have a reference to the body, and we have the body scale. Next thing we're going to do, in here we are going to change from body scale that is equal to the transform. It's going to be my body, so it's going to be the initial scale of the body on our player. We'll also set in here the initial controller height as the my controller dot height. Great. Now let's go into the start crouching, and in here the transform.local scale will be changed to my body local scale, and it's going to be equals to the crouching scale, which is half the size. And now let's change the position of our camera head. So my camera head dot position will be reduced, so this is the minus equals that we've learned, by a new vector, and this vector is going to stay 0 on the x scale. It's going to be reducing the height of the camera by 1.3, and on the z-axis it will not do anything. So why 1.3? Well, because I've already did this before. So 1.3, in here you can change the transform by actually typing in 1.3, and this will be the height of our new camera, which is perfect because our body will also be reduced. So back in our script, final thing we should be doing is we are going to get my controller, we are going to access the height, and we're going to be dividing it by 2. So just like minus equals works, divide equals works the same. It takes the my controller height, it divides it by 2, and then it puts it back in the my controller height. Let's see if all of that works. And of course, this crouching will be equals to true. Back in our game, we are going to hit play, and hopefully all of this will work. So now, oh, we haven't assigned the body. So in our console, it's telling us that the variable my body has not been assigned in player. So back in player, and let's assign it the body. Save all of that. Now we shouldn't get any problem, hopefully. And before we continue, let me just dock this right here so we can see the player. So now we can actually crouch, and you can see we have the, so first of all, the body only changes. Oops, okay, so stop, please. Okay, you know what? I'm not liking this at all. We're going to change the left alt to the C key. Okay, great. So save all of that, back in our game, and we will no longer have this problem. And now we can see that when we crouch, on the left side, you can see that the gun is still the same. Now maybe we need to move the head a little bit up, and now we can move around. We can, so the gun is disappearing under the floor, which is not good. And now we can move under this right here. We are moving at a crouch speed, and when we remove the C key, you can see that we still have a lot of problems, and that's going to be part of your challenge. Is going to be to finish the stop crouching. So you'll need to put back the body scale to its original scale. You'll need to put back the camera head position to its original position, and you'll need to put back the controller height to its, well, original height. So pause the video right now and go do the challenge. Okay, welcome back. So first thing we're going to do is put back the body scale. So body, nope, this should be my body dot local scale is equal to body scale. So this will be our initial body scale. And then we are going to take the camera head. So this is the camera head position, and we're simply going to change this to a plus. And finally, we are going to take my controller dot height, and we'll set it back to its initial. So initial, whoa, initial, please. Okay, let's go ahead and copy it in here. So initial controller height. For some reason, Visual Studio just doesn't want to cooperate. And we of course are going to stop the crouching. Let's just add a bit of space between these so they are not cramped and jammed all together. Back in our game. Now a small thing that I would like to change is actually the height of our camera. So now when we hit the C key, we are crouching. When we release, everything comes back to life and is normal again. Now the height of the camera is a bit annoying because the gun is disappearing under the ground, which is not good. So maybe we can actually reduce this from 1.3 to 1. So save all of that, back in our game. Let's see how that looks. And now when we hit the C key, yeah, it's much better, I feel. Maybe we can reduce it. Well, this can also depend on your preference. So how do you want your game to actually look like? How much do you want to crouch whenever you hit the C key? And maybe you don't want to use the C key. Maybe you want to use the P key or L key or the exit key. I don't recommend that, but you can. So with that said, I hope you enjoyed the video. Before we go, let's go ahead and stage all of our files. So in masters, we have the uncommitted changes. We stage all of them. We click on the commit and added a crouching mechanic. Commit all of that. In the next video, we are going to learn how we can add animations into our game. So I'll see you in the next video. Hey, Michael here from the future. So I saw that when I made the intro, I noticed that whenever we are crouching, we can see this black line right here, which is very annoying. So what is this? Well, it's actually, if we go to the scene, we can see that it's our head right here, and it's getting in the way of our camera. Maybe for some of you, it's much bigger than this. Maybe for some of you, it has been there for a while. I hope not. The way we fix this is we can actually go to the camera, and in here we can see that we have something called the culling mask, and this culling mask allows us to sometimes take things out of our vision. So if we click on the mixed and we remove ground, you can see that in game mode we no longer see anything that is under the ground layer. So we are going to do the same by adding some kind of layer to the eyes. If you want to take this as a challenge, I encourage you to pause the video right now and go do this. Okay, time's up. So go to layers, edit layers, create an invisible layer. So invisible. And now back in our eyes, we'll set the layer for the, where's the invisible? Invisible. So now our eyes should be invisible. We go to the main camera, we go to the culling, and we'll remove the invisible. So now when we hit play, hopefully this works from the first time, and yep, we no longer have the eyes. So some of you might have been having a lot of trouble with this. I hope not. I hope you stay safe, and I'll see you again in the next video. My name is Michael Moore, founder of Double M Game Dev, and my goal is to make you the best game developer in the most fun way possible. I've developed a strategy that has helped thousands of aspiring game developers achieve their goals of creating real-world games, and I want to do the same for you. What I've learned is that it can be very difficult to know where to start and what steps to take to go from beginner to intermediate to professional. Not only in game development, but in programming and learning how to code. And this is where the strategy comes in. We start off by learning the very fundamentals of C# programming, Unity engine, and game design. We then delve deeper into every single aspect. So your game goes from boring cubes to epic weapons, your code from basic to advanced, and your game developer skills from complete beginner to absolute master. And I can say with absolute confidence, this course makes it easy for any beginner with zero coding experience to jump in and start learning how to create incredible games. I've helped thousands of people create real-world games, and I want you to be one of those people. So, how are we going to do this? We delve deeper than any other course into animations, coroutines, character control, particle systems, gun systems, enemy AI, first-person mechanics, health system, a weapons system, and all of those are just the tip of the iceberg. So, what should you expect by the end of this course? You'll become a master problem solver. You'll understand the fundamentals of coding and learn how to program games just like the ones you're seeing on the screen right now. You'll also have the chance to flex your game developer muscles, because with every video there is a mini challenge for you to complete. And even if you can't figure out how to do the challenge, don't worry, I will be there to help you after you've tried and complete the challenge with you. Everything in our game will be configurable, so you can tweak, play around, and give the game an individual and special feel about it. So you will be putting your own creativity into it and really making it your own. I'm so excited to get started and hope you are too. The best part is you don't need to commit to anything. There is a 100% money back guaranteed on Udemy for the first 30 days. This is the perfect time to start learning how to code, so dive in with me and I will help you along every single step of your game development journey.